Good afternoon, everyone. I, Dr. Pranshuman Parashar, co-coordinator of First 17 Days Refresher Course 2022, welcomes you in today's session. So for today's session, our eminent resource person is Dr. Ankit Saxena from JRA University, Mathura. So before we start our session, let me introduce our resource person. Dr. Ankit Saxena is currently working as Associate Professor at the Institute of Business Management, JRA University, Mathura. He is a director medalist from Dayalbagh Educational Institute, Dayalbagh, Agra. He has published a number of research papers and contemporary business case studies. He has also imparted consultancy to corporate entities in developing strategies for business processes. He has been resource person to FDP on research methods on various platforms. So now moving further and not taking much time, I would like to hand over the session to our eminent resource person, Dr. Ankit Saxena, sir. Sir, please.
Thank you, sir. Thank you for the nice words, and really appreciate the efforts that you people have put in for this FDP. And I was going through the entire list of panel speakers and the content that has been drafted for this particular program. It is really commendable job, and I'm sure that all the learners must be getting the maximum benefit from this program. So today in this particular session, right now, let me just start with my things. Though I shared my work files with Nishya sir, so I believe the mail should have been sent, but no issues if some of you have not received the file. So whatever work file we'll be working upon in between,
Sir, I've sent all the files to the participants.
Great, sir, great. So those all work files are with you. So for next this session and the next session, we'll be working upon basically on those files, and some of the files will be, the self-developed at the same point of time. So we'll be working upon those kind of data sets. So in that case, whatever you feel like asking me, if you wish to interrupt in between at that point of time itself, we'll be okay with that. So you can drop your queries in the chat box. I'll keep an eye constantly over there. And in this particular session right now, the first session that I'm taking, will be talking about the application of Excel in the basic analytics. Obviously, it is one of the most traditional, but still very powerful tool for basic analytical things. And what I believe, even today, most of the companies, they are recruiting our fellows and our students. They normally seek the very first thing is the proficiency in the Excel. And if a kid is, if a student is decently equipped with the MS Excel skill, obviously the road ahead is very, very easy. So the topic that we are going to cover, I'm trying to cover in this particular session right now, I'll be talking about basic some Excel function. We'll talk about pivot table, power queries, table, goal seek, scenario analysis, what if analysis, a bit of solver, and then a few things like which everyone in their practical life needed, and that's available in the Excel, like loan amortization schedule. And whenever someone is coming to you to analyze one particular investment, so you can use this XIRR function. So these are the broad ideas that I'm planning to cover during this particular session, right? So let us start with this. Okay. So these E files will be working on the current session, and R files will be using in the next session. We'll talk about the use of Excel for research part. So this is how we are going to deal with this topic. Just give me a minute. So very first thing that I'm starting with is a mixed cell referencing. So in the process, the various tools that I'll be showing you, they have different utilities, and when you work upon advanced data to work, on the analytical parts, these small tricks are very, very handy. So suppose this file is E2 that have been shared with you. So if you go to this particular file, if you see what exactly is there in this sheet, this one first sheet is multiplication, and this is like basic thing that I normally start uh, explaining when I start talking about Excel, because cell referencing or cell freezing and mixed cell referencing is something that is very very useful in terms of saving time. So when you're working on the Excel, and if you are equipped with these things and proficient in these kind of things, so that saves your time when you're working on the Excel like anything. Some of the things might be obviously known to you. So if you will pop up with your message in the chat box, so I'll definitely keep an eye. So accordingly, I can pace my session for that purpose. But my idea is that after next 80 minutes or so, you'll be having some basic idea. Even if you are not having much exposure to these things, you'll have a basic idea about these tools and utilities of theirs, in the business analytics. So for example, normally, if you want to multiply all these numbers at one click, so obviously there are ways that we can multiply one by one, and this is going to take a lot of time. So if I want to multiply all these cells like that, it is going to take a lot of time. So if I wish to multiply everything all together at one click, so there are various ways of doing that. So I'm telling you the easiest way of doing that. So select the entire cell. They select the entire green part of this particular table. And in this case, what you will be uh, going for, you just need to multiply now. And what you see, the first cell is highlighted here as a light green color here. So what we need to do, we need to apply formula over there. So we are putting the formula there. And what I need to multiply here, I need to understand the formula in this particular cell that I want to apply. So I want to apply A5 and B4. So this is something that I want to do. And remember, I've selected the entire cell before putting this formula here deliberately. So A5 into B4 I want to do. And if I'll be doing this straight away and putting control plus enter, this is going to give you something like that, which is not going to be the correct answer. So that's not the right way of doing that. So I'm just undoing that. So what I'm doing, I'm multiplying A5 and multiplying with B4. So here we need to understand how the referencing, mixed cell referencing is going to work. So in this case, we need to understand that, okay, in A column, the first column, I want to freeze this column. I want to freeze this column here. If you just can notice, when I'm talking about A5, so in the further part of the table, I want to freeze A column. So what I'll be doing, I'll put F4 here. And I'm when I put F4 in the Excel, this brings the dollar signs, and that is what we say freezing of the cell. So that's what you are doing. So first time when you freeze it, the dollar sign will appear for both row as well as column. So A and as well as fifth row is being freezed. So what we are doing here, I want to freeze here only A column. So I'm pressing F4 again, and this time fifth row is being frozen. So I'm going again F4, and this time the dollar sign is in front of A only. So that means we are going to freeze A column only here. And this is what the very first thing that I'm doing here. Now moving to the second part of the calculation, this is B4. And in B4, if you can see my mouse movement, what I'm trying to do, I'm just trying to make sure that somehow I should be able to freeze this particular row. So I don't want to freeze B here, I want to freeze 4 here. And the moment I click on F4, the dollar sign will appear, ahead of B as well as 4. I need to press F4 again. I'm using F4 key. And some of the laptop, it might be, working with function plus F4 key. So some HP laptop might be having that programming. So now again, I pressed F4 and I see, okay, now the fourth row is, having that dollar sign. Now the fourth row is going to be freeze. So this is the formula that I want to apply. Let me see whether it works perfectly or not. So I'll just hit Control plus Enter here. And the moment I'll do that, I'll be getting this particular answer. And this answer is correct or not, that I need to obviously check. So we can see whether this particular function is working correctly here or not. So for that purpose, I normally go to formula, and we can use the stress precedent option on any cell here. So see, this is working correctly in this particular cell. We can check some other cells over here, and this formula is correctly working here. So this referencing is going to obviously save our time when you're working on multiple data sheets, and it's a big data, and you have to apply the same formula again and again. So if you are using mixed cell referencing, that saves your time. I'll give you one illustration of that. In the second sheet, we have taken this budget example, and let me tell you, if you give this particular budget to be prepared to a novice, the one who is not having much exposure to the Excel, he or she might take a lot of time. So what we need to do here, we need to prepare this projection of financial statements that we are trying for. So in this case, I want to calculate all these values. And to be honest, for the first time, I gave this exercise to my student, and to my surprise, one student took half an hour, more than half an hour, to solve this particular exercise, because he was doing all the formulas manually. And he probably missed the first session where I discussed about this shortcut, and he was going through that manual calculation for individual cell. And obviously that's not needed here. So let us see how quickly we can do it. So first of all, we have revenue here. So we need to start with the revenue. So the very first number is, B4. One thing in the Excel and financial modeling or business analytics or anything that you are trying to use, especially in the Excel, we must be using as much as referencing possible. We should not be typing values. People have tendency of typing 5,000 here, which might work for this 5,000 set of thing. But if you're trying to change this 5,000 in your budget, you say, no, I want to start my revenue projection with 4,000, then you have to change the entire cell over there. So it's always good to refer cell as much as possible, because that saves your time, and this sheet remains customizable. You can always customize the revenue value also, and then it will be easy for you to customize your final projection as well. So it is always good to refer cell as much as possible. So I'm referring to the cell 5,000. Now I want to see, the assumption is saying that revenue percentage is 0.015, that is 1.5% revenue is going to increase every month. This is what they are expecting. So let me just quickly use this function here. So I can do again same thing. I'm selecting all the months together using the same function. So this previous month value is going to increase by 1 plus this growth rate. So this is simple mathematical formula. And because I want to freeze, I want to freeze this 1.5% for all the cell over there, I'll be using F4 function, so that this is being frozen, and straight away I can close the bracket. And when I want to apply one formula across the cell, you can just simply quickly hit Control plus Enter. And you'll see that, okay, all these values are calculated at one single row. So now all the values are calculated accordingly, and obviously I can check those values mathematically, are they making sense or not. So, okay, this is one thing, this is working nice. So 1.5% incremental sale after January will make the revenue value to be 5075. And eventually it will keep increasing by 1.5%, and this value will be 589.7 at the month end, at the year end, in December. Now the bigger part of the calculation is this expense part. What they have given us, they have given us the percentages of expenses as revenue, and you have to calculate this revenue part. So what you are going to do here, you have to calculate all these expenses, and all these expenses are in certain percentage of the revenue. So what I want here, I want to calculate all these expenses at single click, and using the same method that we used earlier in calculating those tables, I'll be using the same method here. Remember what I'm doing here, I'm just selecting all the cells that I want to calculate, highlighting all the cells, selecting all the cells, then using that equal to sign. And here I'm using, see, one thing is very, very important. I'm just zooming on that particular part of the screen only for you. Then you'll get better idea. So in this cell, if you see, the E7 is right now highlighted in a lighter shade, and you are going to apply your formula there. So when you are typing equal to, you are applying your formula in this particular cell. So whatever you're thinking, to drag across the table, you must, focus on this particular cell first. Okay, how do I want to apply formula here? And that is very, very important part. So just a minute, Smita ma'am has sent, okay, Dr. Sunita has requested to give some hands-on time simultaneously to do it again. That's really doable. We can do that, ma'am. So I will rerun the formula. I will rerun the formula. I just I try to cover a lot many topics here, so that is my aim. But no issue, I can at least allow you for 1 minute to do what we are doing here. That's really the motto of this exercise. So I will allow you for that. Function के लिए Kriti, we are freezing the she's asking for the function of freezing, that is F4. You can press F4 function, F4 key in your keyboard, and that will allow you to freeze. So that you can use that function. If you are using HP laptop or even some other brand laptop I've seen, they work with the function plus F4. So that is the key for freezing. So use of freezing is a very, very important thing for me. I'll explain you that in this example only. As of now, what we were doing, see, if we are not freezing, sometimes what happens when you, let me just give you one example in some other sheet here. So let's suppose this is the example here, and you have this value 200,000, and you want to calculate, you want to add certain values over there, let's say 15, 20, 30 or whatever. You want to add these values over there. So what happens when you say 2000 plus 15, this works well. When you copy paste this formula, what happens, these cells are normally programmed to dragged. So they will be dragged. When you will drag the formula, the cell also, input cell will also be dragged when you're not freezing them. But what I want this cell to drag, but I don't want this cell to be dragged. So मैं 2000 को freeze करना चाहता हूँ. I want to freeze this 2000 cell in any way. So I want to freeze this particular cell. So what is the idea here? E3, when I'm applying in a function, just press F4 there. And here we are not concerned with that row-wise freezing or column-wise freezing, which I explained earlier, because I want to freeze that cell across the row and column. So I will just put it like, both way $ will work. And the moment I hit enter now, this function is working nicely. And the moment I drag now, you see this cell has been, freezed. And this is the beauty of this function, this small key. Thank you for acknowledging the concept. So this is where you can see now this cell is actually, 2000 has been frozen here. So sometimes we want to freeze certain cells. Whenever we are dragging the formula, we don't want that cell to be dragged because it is a constant cell. So that is where this function, is very, very immensely useful. So coming back to sheet that we were working, and what I'm telling you right now is a relatively advanced part of it, but still, I hope that will make sense here. So let us see how does it go. You can keep coming up with your queries like that. I really don't mind that. So what we are doing here, we are putting that formula here. So what is the formula here? I want to calculate COGS of January. So COGS of January is going to be sales of January multiplied by COGS percentage, that is given in the assumption table. So this is the basic formula that I want to apply across the sheet. Now what I want, when I'm going downward, when I'm dragging my formula in the column, yeah, I'll tell you about the formula for revenue. Okay, let me tell you first that only. So how did I calculate revenue thing? I'm just re-explaining for her. She's asking for that thing. So let's say if I want to go for the revenue, so very first revenue, I'm just referring from this cell. So just very first revenue value we are taking from the assumption 5,000 is going to be my revenue, and it is there. Starting revenue for January has to be 5,000. Now remaining months revenue that I want to see what is going to be revenue of remaining months. So for that purpose, what we are doing, I'm selecting all the months till December, and what is given there in this sheet to us, that revenue every month is going to increase by 1.5%. So 1 plus G, that is the basic formula that I'm applying here. And this 1.5%, I don't want to be, dragged. So what I'm doing, I'm freezing it. So deliberately I pressed F4 here so that it is freezed. So 5,000 into 1 plus 0.015. This is the formula that we are applying. And this is going to be, for every month sale. So March sale will be 1.1015 times of the February sale. That's how we are going forward. So clicking Control plus Enter, and you see all the values are calculated at single click. You can do it, multiple times. I'm trying to tell you the ways to calculate in single clicks. That's what I'm trying to build that understanding in such difficult problems. Now, as we were discussing about this particular part, so I want to re-explain that thing. So here we are going for COGS calculation. And as I explained you, January COGS will be multiplication of January revenue into COGS percentage. Now, the only thing is when I'll be dragging this, I want when I'm dragging, in the rows, this 3.375 in the next row should become 0.135. In next row, it should become 0.075. In next row, it should become 0.015 and so on till the last point. And here, when I'm dragging, things in the column, I want in January, we should multiply with 5,000. In February, we should multiply with 5075 and so on. So this is going to be a tricky thing, but if you understand the basic of mixed cell referencing, this can be so easy. Now see what I'm going to do. E5. E5 is this, beauty of the Excel is you can see that differentiation in the color. This red color is B7, this is here, and this E5 is your revenue that is, in the row. So when I'm talking about E5, you just think from your, mind, and you can respond in the chat box. What I'm trying to freeze here, I want to freeze a row here, or I want to freeze a column here. In the revenue, E5, I want to freeze what? E or 5? Your answer, you can respond in the chat box as well. If allowed, unmute is there, then you can unmute and answer that.
5.
5, very good. We, sorry, you said 5. Yeah, we try to freeze 5 here. We want to freeze, yes, right, Dr. Sumita, and right, Satbiji. Nice to see you again. So we want to freeze 5 over there. So what I'll be doing, I can even manually type $sign there. So before 5, I can manually type $sign. Excel will understand what it is. But using the normal trick that we have learned, F4. Now, because F4, is giving you $sign in front of ahead of 5. So that is what you are freezing row number 5 there. Come to B7. And in B7, what you want to freeze? You want to freeze only the column, but not the row. So in this case, you want to freeze only the column. You don't want cell to be dragged beyond B column. You want to keep only in B column, but you want to allow the dragging in terms of the rows. So you want to freeze only B column here. So F4, and again F4, and you can manually type $sign again in front of B. So here you are freezing B. And the magic of the function is when you press Control plus Enter, not the single enter, you have to hit Control plus Enter, and I'm hitting Control plus Enter. All the values, at one click are calculated, and this saves a lot of time. I just make it as a counting number so that it looks not very clumsy. So now all the things are calculated at single click. So if I want to check whether I've calculated correctly, my formula was correct or not, because in the beginning when I learned this trick, I was like, not sure whether I've applied the correct freezing or not. So what I used to do normally, I used to check for the precedents like that. Okay, my June value, my June depreciation value is calculated like, okay, revenue of the June and depreciation percentage of the June. It's correct. Let me check some other value here. So I'm again checking this precedent, and like you can see, October revenue value multiplied by interest percentage of the, that way, and it is giving me correct answer. So that is thing. Rightly, so Sadhguru, it is a magical software. I love Excel like anything. I have worked upon R, Python. I love working on R as well. But this Excel is something that is obviously the first love, and this keeps amazing. This keeps amazing you. The things that are there. I normally used to think that I know 80% of it, and when I learn new things, I always feel that 80% is not yet known to me. So it's something that we should always try. So okay, now quickly calculating the other things. Now I want to calculate total. For total, you can use one shortcut that I'm typing here. You can use Alt equal to. So once you use that Alt equal to, this automatically calculates the sum over there. So when I'm pressing Alt equal to, by default it sums the entire row accordingly. You want to calculate total of all these rows, so you can again select all the rows and use this Alt equals to, and you'll see the speed at which this calculation is actually happening. So this is something that is something that you should, be taking care. So you can use this small shortcut of auto sum, alt equal to, and then you go for the total expenses. If you want to calculate, again, you can select all these cells over there, and pressing alt equal to, quickly will calculate all the sum, and you won't realize how quickly it has been done. So if you see, all the sums are correctly calculated. So alt equals to works horizontally as well as vertically. I've shown you both ways. So if you see here, I'll just do it again for you. So the moment if you want to calculate, total of the, row, you can quickly click here, alt equals to, you see, it is done actually. The moment you'll hit enter, you'll calculate all the values. Please remember, when you are going for multiple cell answers to be, explored at one click, you must press control plus enter. So sometimes, what happens, because we are used to hit enter only, and we are not accustomed, the initial programmers are not accustomed to this particular thing. So what they normally do, they hit enter, and that won't work. So if you will select all the things, and I'll just show you what mistake normally people do. In this case, though, like we are using the formula, so alt equal to is obviously a formula that we are using. So selection will be done, but most of the time when you hit enter, that is where the answer will not come. So now we need to calculate net income for all the months. We want to calculate monthly total income. So that's doable. Again, I've selected all the cells, and we'll go to the revenue part. And yes, Pushkarji, if you're using LibreOffice, actually, I've not worked upon it, but yeah, one of my students was working on it, and that same problem he also faced. So yeah, it's probably not working there. So then in that case, you have to drag. So once you have calculated a cell, so you have to drag that particular cell to the other cells like that. So that's something limitation over there. So that you can manually drag in that case. Now I've selected all the cell, and control plus enter, I'm working. So I've got net income of individual months correspondingly. So you can take, you have this worksheet with you, E2. You can quickly try and see if you're facing any difficulty in getting any value. I can reiterate the point. I've chosen, very few useful methods that I normally use in class, that I normally use while working on some big data, so that even if somewhere, if you're working, and Excel is something that we are always working on, even as a teacher, as a researcher, as a corporate person. So we are not away from the Excel. So these are small tricks, saves your time, increases your efficiency for sure. Can we move to the next trick or next tool?
Yes, sir.
Right, thank you. All right, okay. So this is done. I'm just saving it for the future reference. Now moving to the next trick here. Let us see very quickly. It's a very small thing, not much talked about thing. VLOOKUP, HLOOKUP we'll be talking about in the later part when I'll be working on the pivot. I've integrated that example there. So we'll be working on that thing. So this is I'm talking about pivot table here. So let's say this is the okay. This is the table feature. What table feature actually does, and how does it saves your time? I'll just explain you with few examples here. We in our lives, even me, because we are working at a university. So in a university, it is inevitable, because I look after the examination also. Sometimes we are involved in some, other administrative works too. So obviously the Excel data is always there. So we are playing with the data n number of times. And one very simple problem that has been there, what used to be there, when your HOD or your director, or he's sharing some file with you, and he's asking you to give you a report. So you normally, what you normally do, you do the stuff, you do the analysis, and you submit that file. You give them that file. And what they normally do, they will always have a reminder mail, and then they'll say that we have got some more data now into added into this, and please work upon this data and give me the refined report. And you feel like I have to do this particular step now all together again, and that is what normally happens. So something, if you normally know about the table feature, it's a very small unknown feature in the Excel. Few people obviously know and they work on it. So what I've realized, if you know the table feature, it saves your time like anything. Let me give you one example here. For example, this is the table over there. It's a normal market data table. So products are there, suppliers are there, cost is there, retail price is there, and they have created one drop-down menu like this. Let me just show you how do we create this kind of drop-down menu for your reference also. So if I want to create a drop-down menu here, so what I need to do, I need to go to the data. In data, just a minute. Sorry, not data. You should just go to just a minute, just a minute. So in this case, we need to go to the data validation here. So we will go to the data validation. So for example, in this cell, I want to work upon it. So select this cell, go to the data validation. And in data validation, you select here list. And the list, you have to define the source. You can even type also. So you can type, if you have some specific item, you can type that list also. So you are going for a list. And the source I'm telling is this, the products. So what I've done, I've gone to the data. In data, I've gone for the data validation. In data validation, I've gone to the list, allow list. And in some of the Excel, you must have seen they don't allow to enter something that you don't want to allow. So then in that case, this data validation works pretty well. So you can actually define whether I want only a number, I want only a date, I want date only in a format. So sometime when you're preparing data for any official purpose, so and multiple people are working on the same sheet, this data validation function, works pretty well because everyone will have to enter data in one particular format only. So it will be always easy to compile data, when you are collecting data from different. So here we are going for the list. We have selected the sources from the product and clicking OK. Now what it does, it it is giving you one particular values over there. What they have done, they have applied a VLOOKUP function here, and it is again a very, very prominent function. I've told you about creating a drop-down menu. The retail price is, you want to calculate the retail price of the product that is being selected. So in this case, we can simply apply VLOOKUP. I want to look up the product, lookup value. What I want to look up, I want to look up the product, comma, where I want to look up, I want to look up in this table. I want to look up in this table. So that is going to be the table, comma, because I'm not going to drag this formula, I'm not freezing anything, be clear. Then in which column my answer is there? My answer of retail price is in the fourth column of the table, 1, 2, 3, 4. So my answer is in the fourth column. So I'm putting 4 over there, comma, I want exact match. So my product name, if it is Carlota here, so then in that case, the exact retail price of this only product I want to get in output. So I want exact match. In Excel, 0 means false, 1 means true. So I can put 0 there and hit enter. Now it is going to work. So if you see, okay, this particular product has retail price of 27.95. And if you will change here, because you have made a drop-down menu here, so if you will change the product, automatically the answer will change. So this is a simple automation that we normally try in our models that we build. Is it clear? Because I've told you here two things: data validation part, creating our drop-down menu, and then I've also told about the making a VLOOKUP function that is working here. Right now, moving forward here, what is the limitation of this exercise? Because we are working here now. Let's say if I want to add one more product here, and let's say I'm just typing XYZ, not promoting any product for any reason. The moment I hit enter here, any product, and I enter some details about that product, and this detail is not going to be definitely added in this list that I've made. So when I enter a new product here, I have to again make my list and then again adjust my formula, and this is going to take time. Now, what is the remedy here? A very small trick that saves your time like anything. You just come in the table. It's the down fight of the table. We are working in the E3 right now. So you just come in this table, hit Control plus T. Control plus T. I'm just typing it here loud and clear so that everyone is getting this. So what you need to press? You need to press Control plus T. Just use this small function here, Control plus T. So now what it is going to do, let me just tell you what is the power of this function. The moment you hit this Control plus T, you are here, you just hit Control plus T, this kind of option will come up. This is creating a table, and because my data has header, I'm selecting that to be true. I'm clicking OK here, and suddenly you will see your data has been converted into a table format. Now you'll wonder what is new in that. That's okay, that is done. But you see the magic now. Here, I need to create a drop-down menu. So I'll again quickly go to the data. In data, I'll go to data validation. In data validation, I'm selecting list again, and I'm selecting similarly the source of the products list. Okay. Again, I'm applying the VLOOKUP function here. So VLOOKUP, I want to look up the product. I want to look up that product in this table array, comma. My answer is in fourth column, and I'm looking for the exact match. So this is how you normally go. As of now, nothing is selected. इसलिए answer नहीं आ रहा. The moment I select product, my answer will start coming. Now it is done. Now what is the fun of doing this? If I copy this data over here, now suddenly what you will realize that the moment you go to this, drop down, this has this XYZ function also. And the moment you click on the XYZ, it is giving me the answer also. I didn't change my drop down menu. I didn't change the VLOOKUP function. That all was saying. The only difference that I did, I made my data into a table format, and that is by using a small function that is Control plus T that converts any simple data into a table. So this is one utility of this. I'll show you another advanced utility of that. Sometime what happens, we work on I work on basically financial time series data. So yes, Pushkarji, that is that is going to be a limitation, that some features are actually not available in the LibreOffice. So even Google, Excels are having many good functions nowadays. They have refined Google Sheets like anything. But yes, still Microsoft has an upper edge in this thing. Google Sheet is very good when you're trying to integrate something with the web. So something that is available on the Google, they have done some very fancy, tremendous features over there, because they can fetch details like anything. So if you want to fetch prices of a stock, Google will do it for you in single click. So that is the beauty of the Google Sheet. But here, this is a limitation in the LibreOffice for sure. Now, for example, if I'm making a pivot table here, it's a small data that I'm putting you, giving you here. Suppose this is the data, and this is a topic that I guess most of you must be knowing, but if you don't, you can learn very quickly. Nothing is like coming from any other planet. So you have this data with you, and you want to create a table out of it. See, the raw data is always having a lot of information, but no, interpretation can be made from that data. So if I want to see my product sale is going which way, which product is making most of the sale, and what other things I want to calculate. So for that purpose, I need to make pivot tables. So I'm going with the pivot table. I'm making the pivot table here only. I'm just putting that sheet here only. And you see, the moment you make this pivot table here, this pivot table is looking blank, but it can do wonderful jobs. We'll discuss that in the next exercise too. So what I'm doing here, I'm just selecting products in the rows. I've selected products in the rows. I've selected units sold in the values. So it is giving me some of the units sold. Very simple, very simple pivot table that I'm making here. So now the problem with this pivot table is this is the new record that obviously sales is not a one-day exercise. It will keep on increasing every day. And as a marketing manager, as a sales manager, you need to make these reports every MIS reports day and night. So even in the academicians, we are working on the financial time series data, and I was working on some problem, and I started working on that problem in mid of January. And I knew that I'll be asked by the editor of the journal to complete this data and have this financial year completely into that data. So I just wanted to continue with the basic things and make the raw financial model, business Excel model for that purpose, so that whenever I'll get the remaining data, I'll just add it here and the other things will be done automatically. But because here I have not converted this data in the table format, if I paste it here, nothing will happen to my, even if I refresh here, nothing will happen to my sales. It is still 1944. So that is one problem here. So what is the solution part here? I'll just tell you the trick. I'm just removing this pivot table for a minute. Just select the table. Somewhere you click in the data anywhere. You need not to even select. You just click data, in the data anywhere. You just press Control plus T. And the moment you press Control plus T, it will again ask you whether your data has headers. Yes, it does have. So we'll say yes and click OK. Obviously, you can have multiple formatting design as per your liking. So I'm not going in that detail right now. So it is one of the by default custom table template. So it's okay. Now, if I go and make the pivot table here again using the same function, so I'm just clicking here, okay. Using the same thing, again dragging products to rows, again dragging unit solds here. 1944 is the answer. Now I've got new data. I'm just cutting that data and pasting here. Now what happens? The data has been pasted in the table, and I just need to refresh my pivot table, and you see the answer is changing. So this again, is a wonderful, wonderful tool where you can save a lot of time. So please, you can take a minute and try and do it on your own. And if you're facing any difficulty, you can ask me right now. Table can't overlap error. Sumita ma'am, sorry. You have to now make sure that whenever you are giving the output range, your data should have empty space, enough empty space. So if your data has enough empty space, then this table overlap error will not be there, because that might be one of the reasons. And when you're getting this error, when you're pressing Control plus T in that case, or when you're making pivot table, then you're getting this message. Control plus T. Okay. And which version of the Excel you're using? MS Office, which version you're using right now?
Sir, I'll just check and let you know. I think it's 2021.
Because I'm on the 2021 right now. So it is, sorry, it is 2019, not 21. I was thinking to upgrade, but as of now, I'm working on the 2019. And this message, this, Control plus T command works. I've been working on this command even in the 2007, it was working well. So this works well on across the formats. You just try it and do it again. Otherwise, after the session, I'll drop my mail ID, so you can connect with me on that, and I'll definitely help you. It's nothing like that. This 1.5 hours is only time where we can interact.
Yes,
for learning, we can definitely connect anytime.
Okay.
So ideally, but I hope you're understanding the power of this function. The advantage of making any simple data and transform the data into table is that you are able to play with that data at your ease. That is one big advantage. So this is the table thing. And suppose one simple thing I'm telling you, this is like most basic thing. If you're saying that, okay, I want to see till date, whatever sale I have made, there are 636 rows in this data, and I want to see what is my total sale. So I just apply this sum function, and I'm just hitting Control plus Control Shift down, and this selects all the data. and hit enter. So my total sale as of now is 60,768. And what is my maximum sale on one particular day for any product? So I can use max function here. And when I again hit control shift down and enter, I see 191 was my highest sale that I've got any day. Now it is natural that you'll have some more data. I work on the examination data, so we keep on accumulating data. Exams are getting done and we keep on accumulating data. Students are there. So new students, new exams data keep on coming. Obviously systems are there, processes are there, but still sometimes you might be working on the raw data for your result analysis or something. So you just copy this data. Now new data you are copying, copy this data, go down to the bottom of this data, paste here. Nothing is going to happen because I didn't convert this data into the table format. So nothing is happening here. But what should have ideally done if I would have made this table, control plus T anywhere in that data, and this now is a table. You can see that difference in the color now. It is a table now. And the moment I now copy paste this data and go down to this sheet, control plus arrow keys saves your time. So pasting this data, and you see this is pasted in the table format straight away. It doesn't even ask you. So now you go back in the data. Now you see that total has changed. Earlier it was 60,000 something. Now it has automatically increased. Now if you see 200 here, so the max function is changing and total is changing. So that's working well. So whatever, even you are making a chart. I'm not going into that example, but if you are making a chart, so let's quickly do that. If you make it a table, this is a table now, and you make a chart, a simple line chart. So if you make a simple line chart or any chart like that, so this is the chart that you have made. And when you enter a new date over there, so suppose you are entering another date here. So let's keep it another date here. So this is another date over there, and we have another value over there. Let's say 6,000. So what's happening on the right hand side? You can see, suddenly you see that 6, 7, 8. Let me keep it 9. So now suddenly you see what's happening here. What's happening here? Then you just converted your data into table. You made the chart. Then you entered another date value. The chart was automatically adjusted. If I would have not converted this data into table, this would have not been possible. So that's the important part of table feature. So not saving what I've done here. Moving to the next exercise, you can take your time, and if you feel like having any confusion, I have a tendency of running on the Excel. Sometimes I go fast, I know, I try to be slow. So if you feel like that it is fast, you can always tell me to repeat something or re-explain anything. So I think we are good to go. So we have done table feature, we have done mixed cell referencing. One more important thing that I want to discuss here is pivot tables. And there are a lot many things. You must have seen the pivot table for sure. You must have seen by now working on the pivot table, but I'll try to give you some idea how we can work upon the pivot table in a different way. So I'll work first in the basic way that we normally do, and then I'll show you another way of working on the pivot table. That's a bit advanced method of making a data table and then connecting the tables and then working on the pivot table. So that's an advanced thing that normally people don't use, but let us try and understand this here. We have sales data over there. We do have sales data here. So you see in the first table we have date, product, country code, unit revenue, and cost of goods sold. Then we have country name, which is not there in this data, but I can fetch it from here because we have country code over here. Max is Mexico, so FRA is France. So I can fetch the country name from the country code from this data. This data can help me to get this from this table. I'll be able to calculate this country part. And the second table, if you see, the second table that we have with us is this product table. So we have product category. So the product category is missing here, but we do have a product over here. So I guess somehow we'll be able to calculate product category, from here to here. So this is how we can obviously use some Excel functions over there, and we'll be using some things and will drag the information into this. So one simple thing is you do this dragging of the information from one table to other table. In the next phase, I'll be telling you how to link the tables, and then without dragging these information from one table to other table. In fact, three different tables can be merged together for making a pivot table. So that's what I'll be talking about in the next 5 minutes. Once, let us do this particular part. So how we are going to do that? Again, we are going to use a VLOOKUP function. Nowadays, the advanced Excel users use, match index. There are different advanced. If you're using 365, you can use XLOOKUP also, because VLOOKUP has a limitation. The limitation of the VLOOKUP is that I want to look up this value. I want to look up this value in this table. So the lookup value, country code has to be in the first column of the table. That is the limitation. Again, I repeat, the product I want to look up in this table, and the product has to be, in the first column. That is vertically, it has to be in the first vertical column. So then only vertical, lookup will work. Otherwise, it is not going to work. That is a limitation. So sometime manually we have to adjust. For example, like this product would have been here. And if I'll be trying to apply VLOOKUP function into this table, is not going to give me the answer. I have to work upon the match and index and some other ways of, looking up. So what normally you can do always, okay, I want to look up product and want to get answer the product category. And here the product is going in the last column. And I know in VLOOKUP, we have to have the lookup value in the first column. So what I want to look up, I want to look up product, and the lookup value is in the last column. It is not going to work. Let me cut and paste it in the first column. So that's a simple way. Sometimes people say my VLOOKUP is not working. So because they don't have the lookup value in the first column, that's why the VLOOKUP is not working. It is the most commonly used function, obviously, in the Excel. For long, people have been using it. So now let us see how do we fetch information from one table, in the other table. So here, let me apply this function. I'll just zoom it for you so that all of you can see it broad and clear. I want to get the country name. I want to get the country name because what is going to happen if I just make a pivot table from this data, I'll be having table with the country code, and some people may not be aware that what this DZA is. Prominent name, all of us know. We don't know this PER is for Peru or some other country. So that might be a problem. So what we need to do, we need to make sure that somehow we should get the country name in this table. So that's what the idea is. So I'm using VLOOKUP function again, I guess for the third time in the session. So VLOOKUP function, what I want to look up, I want to look up country code. I want to look up the country code. So I'm looking for the country code, and I'm not freezing it because when I'll be dragging for the next row, I want formula to drag this particular input cell. So I'm not dragging it deliberately, comma. I need to specify table array where I want to search the C4. I want to search the C4 in this entire data sheet. So what I've done, I've used Control Shift down and then right. So now you might wonder how to proceed in the formula. So need not to worry. You just hit comma because your formula is still working. You are not able to see, but still it is there in the syntax function over there. So you can continue with that thing. And this, formula is still active. You can see this formula is still active here. So we have been working to this formula now. Now what we need to do, it is asking us for the column index, which column you want to go. In the table array, your answer is in the second column. First code is code and second is country, and I want country name. So my answer that I want is in second column. You want approximate match or you want exact match. In such cases, we always want exact match. So I can write 0 or even I can use exact match and then hit enter. So I'm using 0 and enter. Enter here, and we are getting answer here. So MEX is what? MEX is Mexico. So that has been fetched from this long table. And definitely by double click over here, my all answers will come. Oh, one mistake I've committed. This NA has come, and the answer of this particular cell has not been achieved. And what was the mistake? Let me tell you. What was the mistake? Let me correct that mistake here. I did not freeze the table cell. So what's happening? Let me show you what's happening here. When you're dragging the formula here, you see the table array is shifting. So while coming to the, Australia, AUS here, so this AUS, and AUS is actually just above this selected table array, and it was not able to find that answer. So the mistake that we committed, we should have, used the freezing in the table array, and that we skipped, and that is why the answer was not coming. So what I'll do, I'll quickly fix my error, and I can do it again after applying the formula. Press F2. The moment you press F2, you can go to the K4 and L129. This is table array. F4, you have to press now this time, again, going to the both the table array syntax. So either you can reselect the cell. So that would have been ideal, but now even still this will work. So I'm hitting enter, and now let me drag and see, this time it will work perfectly. Australia is also being covered because now it is not being dragged. So it is very important to understand when not to allow to drag. So when you are dragging something, your formula, I want this AUS to be dragged, but not the table array to be dragged. So something that I don't want to be dragged has to be freeze. So that is something that you should, as an financial modeler or working on the data and in the analytics, we have to deal with these kind of issues. So that is done. Let's move to the second part. Product category. I want to fetch the product category and VLOOKUP. I want to look up product, comma, where that product is lying in this table. I need to freeze it, freezing it with F4, comma. My answer is in now fourth column because product category is in fourth column in this table. So I'm going with 4, comma 0, exact match, enter. And a simple double click at the corner bottom there will drag the values for all the information over there. So is this making sense till this point? If you will confirm, then we can move forward. Is this making sense? Or you have any doubt in this right now, what we have done? Okay, thank you. So let us move forward. I got, okay, that's okay, right. Thank you, Pankaj. Thank you. Done, very good, Sunita. So now I want to apply, VLOOKUP here. I want to apply VLOOKUP here. So VLOOKUP we have applied. So I want to make an insert pivot table now. So I'm just going in the insert and clicking on the pivot table. And let me just first select the entire table. Selecting the entire table, making a pivot table out of it. You can go to a new worksheet also. So I'm going to a new worksheet. And see, the beauty of the worksheet is that pivot table fields, you are having so much to do with this. It's all about data presentation nowadays. How do you want to present your data? So if you want to tell that my country wise, so if I'm just selecting country as a filter, so I've just put country as a filter, my products are in my rows. So this is like all the products that I'm selling out are there. And I want to see what is my revenue. So I'm putting revenue in a column. So some of the revenues by default, what they are doing. I want to see my COGS as well. I'm putting my COGS also. Let us remove the COGS. I want to see my product category wise, things. You see how quickly, Excel is calculating all this stuff. So it can work on even big data like that. So a lot of big data, we have worked upon. Obviously, Tableau and other softwares now have come, and data visualization, is something that is where the Power BI and other these Tableau kind of softwares are having an edge over Excel. But yeah, I can do that. Definitely, I can do that. I'm just deleting this entire sheet and making it all together, differently. How do we make a pivot table? So just select the data, Control A, you just select the entire data. First of all, you need to come in the data. This is the data that I want to make pivot table. So you just come in the data, then hit Control A. That Control A will select the entire table by default. So you select the data, then come to insert, and insert you come to pivot tables. And now it is asking you where you want to make the pivot table. You want to make it in a new worksheet or you want to make it in the same worksheet. So I'm going with the new worksheet here. So new worksheet is there. So clicking like that, and this is the simple pivot table fields that you will find. Now, what happens here? What happens here that if I want to see product wise, sales report, so I can just drag product to the rows. How many units I have sold, I can see that. How much revenue I have earned, I can see that. Uh, if I want to put country in a filter, that I can do. I just selected product category in columns. So just the way you want to see the data, it's up to you to play with the data, right? So this is how you can play. Now, what is the use of this filter? Now, country is there. Country is there, and it is having all the countries data over there. So if you wish to see only data of Singapore, so you just click Singapore. So now this data is only giving you the number of Singapore. And if you want to have data of Austria, so you can just select the country Austria, and all this data will be only of Austria. If you filter, remove this country here, and you just come here. What we are doing, we are having country and then product. The sequence is important. So we are saying, okay, country wise product report, and now you can scroll down and you have all the data country wise, product sales data is there. So for each country, you have all the numbers like that. So this is how, data starts working. Now, another thing, I hope this is clear. By this time it is clear, right? In pivot table, thank you. So in pivot table, one more thing that we can do, which normally people they forget and they don't do. So I'm just keeping it simple for you as of now. Removing the country part here. Here I'm just removing country part from rows to filters only, and so that data is not too much beyond the visions of us. So I'm just inserting a slicer here. I'm just inserting a slicer here. So what I've done, I've just clicked on this insert slicer, and I'm clicking on the insert slicer here. Now what it does, it's a magical tool to see some of the information over here. So what I'm doing, I'm going with the date. I'm going with the date, and let me use some other filter here. Let me just remove this. Sometime you can, even do just a minute. Disabled invitations by video, whatever is there. So it distracts the others for that purpose. So sometimes you can have the date data here, and you can drag the date function and drag the date function over there. So now what happens if you see what we are seeing, that automatically this Excel, what it has done, it has already converted the day-wise data into yearly data. So if you want to click here, so you can see that how this data is placed. So quarterly data has been, it already has, automatically it has done it. It has converted my daily data into quarterly and annual transform data. So this is beautiful function. It was having, if you remember, the data was in the date format. So by default, when I'm dragging the date in the rows, field of the pivot table, it is transforming my data into quarterly as well as annually, because obviously daily data might not have much significance to my thing. So that's what it has done. So now you go to pivot table analyze, and then you click on the insert slicer. And now in this case, if you will see, you will have new things over there, that is quarter and years. So I'm going with the years just to keep it very simple. So I'm just going with the years 2016, 17, 18, and you can right click here, and you can go to the slicer settings and hide item with no data. You can do that so that unnecessary information will not be there. Now what happens here, because all the countries are there, so what I can do, if I click on the 2017, this information will be only and only available for 2017. Let me remove date from here so that it will be more visible and clear to you. I'm just keeping product data here, right? So product category wise and filter that is working here. So if I want to see 2017 Australia data, I'm able to see 2017 Australia data. It is only 2017 data. If I will click on 2018, so this will give me only 2018 values like that. So obviously you can go back to 2016 also. So similarly, you can make another slicer. You can have different slicers for that thing. Remember, one small thing, when you're clicking here, you don't see that pivot table design feature here. When you click in the pivot table, then only you'll be seeing that pivot table analyze feature here. So that is important. Sometimes people say, sir, we are not able to see from where to insert this slicer. So you just need to click somewhere in the pivot table, then you'll automatically see it. Now click here and you can add another slicer here and you can say, okay, I want to have slicer for my country and click OK. And now what you will see, you have another slicer here and you will have obviously a bigger slicer this time. You have all the countries over there. So this time we have already selected 2016. Let's say if I say Armenia, so this now is giving me only values of Armenia and 2016. So now two slicers are working all together, at the same time. So I want to see Belgium 2017 values. This is now working that way. So slicer is another very, very important tool that we must probably use in the classes to filter data and see how this particular, sale was dipping in one particular quarter. What was the reason, for a certain drop or rise in the market values or whatever. So this helps in that particular explanation for sure. Next is we have timeline. So I'm inserting with the timeline, and obviously timeline can be date based. So this is the timeline data. Now in the timeline data, if you want to work upon one particular segment of the data, so by default 2016 January is selected, so you can drag this. This is like a data that you can drag. So you can see now what's happening. May 2016 onward data we are selecting, and we can drag this backward also. So sometimes people are working on data of recession, data of COVID or something like that, where you're working on a particular duration and you want numbers for that duration only. So how my GDP was working when the pandemic was on, still it is there. So how it was working in that particular time frame. So then you can actually use this timeline, and it is going to give you a way of filtering the timeline. And in fact, if you just click on the July, so you'll come to know in Belgium only 5 products, 6 products were being sold in that particular time. So obviously now we can have Argentina, we can have different things. So slicers are working, timeline is working. All these things together in the pivot table makes pivot table more interesting. This is the point. Let me see some of the. This is the.
Dr. Sumita this side. I had one query.
Yes, please do.
I had simultaneously, inserted slicer in the data Excel file that you had shared, but I
Right.
have somehow missed out how you converted this date slicer into years. So if you can share this once again.
Yeah, I will tell you. Someone is asking to share the screen. Unfortunately, I won't be able to do that because only 20 minutes are left and a few more topics I want to cover. Definitely, I'll drop my email ID with you. You can connect with me, and at some free time, we can definitely take up your queries. I'm always very keen in terms of responding to all the academic queries that comes my way. So I'll say apologies for that, not to allow you to share your screen. I hope because that is not feasible for all 91 candidates to do that right now. What you are asking, I can definitely give you an insight for that thing. So I'm just removing all this slicer and timeline for a minute. Removed all these things. Normally, what will happen when you will see, just remove this. Normally what happens when you have this kind of data, and sometimes what happens, the new people, those who are working in the pivot table, and they see where my pivot fields have gone. So it's very easy. You come to pivot table, click on the right click there, and then show field list. It will come back. So when you are not seeing quarter years over there, so very first thing what you should do, you should drag dates to the rows. So the moment you will drag date to the rows, Excel by default, will consolidate your daily data into quarterly and annual data, because it understands that someone who is making a pivot table from this data may not be interested in seeing the daily numbers. So this is the by default function. The moment you'll do that, you'll notice that it has converted dates into quarters and years. So now it will come up when you are going to insert the slicer. This time now you are going to insert the slicer. You will see quarters and years also there. If you will not do it, then probably they'll not appear. Is it working? Just first thing you need to do, be in the pivot table, drag this date in the rows part. Yeah, now she could get it. So that's the only trick in this case. Now, this is one thing I've told you about VLOOKUP, consolidating the data, making a pivot table. We can make thousands of pivot tables like that. And then in that case, we can insert timeline. We can use slicer there. That is also, enhancing the, explanation sometime in the class. Because when I want to discuss, company's performance during a particular duration, how the companies were behaving in one particular duration, and after that recession was over, how the companies were behaving. So this, slicer and timeline are immensely useful techniques. Because when the COVID started, the market was in different shape. Now the market is in different shape. How much is the recovery? What is the current state? Can you compare two screenshots all together? So I normally go at very fast pace at times in my class deliberately to see how much they can connect with that speed, because it needs a bit of connection. Though in these online sessions, definitely we need to understand, because if you are doing all together at the same time, it will take some time. So one thing that we have done, another thing that I want to share in this thing is another file that I've shared is E5. The same file, actually nothing different here. Same file is there. It is the similar data, pivot table relationships are there. So let me just work upon that file. We have around 18 minutes left, so probably we'll be able to cover two more things over there. And if something is left, definitely I'll pick up from the second session. Now see, so this is the data here. We have similar data, very similar data here, very similar data here. I want to make similar pivot table, but I don't want to use that VLOOKUP thing. Sometime, I was working in the NAC criteria 5 in our department, university, and there was a lot many data were coming up, and every time, it was very difficult, to give the report that they are expecting to get. So what is good, part, if you're supervising someone, if you're telling someone how to do it, university roll number was there in, because if you work on the student data, the roll number, university roll number is going to be there. So how much scholarship he's getting, how much placement he got, whatever activities he did, and all that stuff. So then in that case, what happens, you can normally, have one common, column in all the tables. So sometimes you must understand there must be something common in the tables, and that commonality, can be used to link the table with the other table. So that's what we are going to do here. And let me explain you what I will be making things like looking like here. Just making you understand. Here we have country code, and in this case we also have country code. So we can connect these two tables. We can connect these two tables. And if you see here, we have product, and here also we have product. So we can connect these two tables using this product. So something common we need to find. Very first thing is we need to find something that is common in 3 different tables. What I'll be doing right now, I'll be making a pivot from 3 different tables altogether. So we'll be taking data from 3 different tables and making single pivot tables. So obviously, at times when you are having 5, 6 data, recently we are working on a project where we are working on a few, different economies there. So now date is common thing over there. We are having data that we have retrieved from some portals. So date is common thing. So what we are doing, we are, connecting tables from the dates, and that is helping us in working, on different markets data file altogether at once. Otherwise, it is very difficult at times. You are just copying, pasting, sorting the data like that, and it takes a lot of time. So just to safeguard that, this is one way that I'm trying to explain you. So let me just show you how does it work. I hope you have understood the mechanism that we are talking about. So very first thing is I need to convert these into tables. So first thing that I'll do, I'll be converting this data into tables. So I'm just clicking in the one table, typing control plus T. I just hit control plus T. Exactly, Sapreji. It is the key thing there. So we are going with what I did. Let me just do it again. In the first table, I'm just pressing Control plus T, and this is the sales data. This is like having sales data. So I'm just giving it a name here. I'm giving it a name, sales data. You can use space also. It is not a spaces who's going to deny. So, okay, oh, it is denied, sorry. And you cannot use a space here. So I really forgot here. You cannot use a space here. So you have to use a single name data here, not having any space. Underscore will do. So, oh, it's not even allowing that. Let me see what's the problem. Control T. Okay, it's here not. We'll be giving name at the next step. So just click OK. And here the table name is coming up here. So here you can give the name. So here you can give the name and yeah, underscore will be allowed. So I'm just giving it sales data. Sales data, not let me just enter space over there. So this is sales underscore data. Do it same here, Control T, okay. Another table, and I'm giving it country data. So this is my country data, country underscore data. Third table, Control T, enter, and this is my product data. So this is product data, product underscore data. So now I have created 3 different tables here. And once you come in any table, you will see the table name is changing now because we have a specified table name also. So you can have a look at table name. So you are swapping across the tables and the table name is also changing. So this is tables like that. Now, what to do next? We need to make a relationship here. We need to, relate these tables. So what we have done, we have converted simple table into tables, data into tables, Control T, and we have assigned them names. You can skip that particular function. You cannot assign a name, but it is always good to assign a table name so that you remember, what table is talking about which variable. If you're working on 5 different countries data, so you must specify it is India, it is USA, whatever. So here I'm going with the relationship. And you will find the box is empty because we have nothing specified by now here. So clicking on the new, I'm specifying a new relationship. I'm specifying country data. Second table that I'm connecting is product data. Now in country data, sorry, I need to specify sales data. Sales data I want to relate. Sales data I'm relating with product data. And in sales data and product data, one thing is common. One column is common, and that column common is product. One column is common, which is product. In both the table, you have product column. And this product column is going to link this particular table. So what I've done here, I have used sales data and I have used product data, and the column that is common in these 2 tables, that is product. So I'm going with the product here, clicking OK. This relationship has been established. So my relationship has been established. Now I need to add one more relationship. Sales data, I want to relate with the country data also. I've related sales and product. I want to relate sales and country data also. So in sales and country, one thing is common, that is country code, because both the tables have same country code data. So again, you need to just connect the common column in the 2 data sets that you have already have. So it might look it might look to you very complicated at first step, and if you have not done it before, but once or twice you'll do it. You have this data file with you. Excel is Fun is one very good channel that I've been following for long, way back. It is a very old channel. Earlier it was very orthodox. Now they have also come up with some new channels, and these templates are from there only. So that you can follow. So this recording probably will be shared with all the participants that you can refer. So once or twice you'll practice. This is actually very, very doable. And see, what I believe that when you go in the class and you just talk about the pivot table, everyone say, sir, we have done it. And the moment you start doing such stuff, they get like, we didn't know about the slicer, we didn't know about the timeline, we didn't know about this connection of the relationship of the data. So something that is there and that you can obviously flaunt, and obviously that's good for the learning and efficiency as well. So I'll do that connection here. This connection is done. Now the connections are done. 2 connections are done. You need to just close it. Connection is done now. Now what you need to do, you need to come to insert, and this time you have to make a table, not from the table. You want to make table from the data model. So you are making this time the pivot table, not from the table directly. You are making that pivot table from a data model. So click on the data model. And again, it is going to ask you where you want to actually make this pivot table. So let us make it on a new sheet. Yes, Babita. Sorry, a new sheet they're asking for. All right. I thought sometime, earlier what used to happen, let me share what she said, and I don't know what she's asking for. She's probably asking for some other thing. But when we were having a lot of data now, we were having lot many Zoom sessions, lot many things. And at times, we were obviously as a teacher, the university expect that you to maintain proper records of attendance and everything. So what you normally can do, if you are using Power Query along with this, pivot table features, it was so easy to settle down even the attendance part. So she's probably asking in some other reference, but I just recalled my learning of this tool, in that COVID time. So it was a blessing to know this. Otherwise, people were wasting hours to compile and sort the attendance and all, uploading the attendance on the portals and all. So now what you can see here, we have country data, we have product data, and we have sales data. So 3 different tables are there. The beauty of this thing is that we can actually now make the same table, dragging product here, dragging product category from here, and then you can define country code in the filter. I'm using the 3 different things I'm using from 3 different tables, and then we used probably revenue part over here, and that's like that. So what we did, we related 3 different tables. We made the same pivot table here. And actually, we didn't use the VLOOKUP, and we combined 3 different tables like that. So, is this making any kind of logic to you that this can be used somewhere for sure? I guess, right? So this is another tool that I wanted to share. One more thing before closing the session, we have 5-6 minutes over there. So one more thing that I would like to address you on this part. One more thing in this sheet only, you can see here, if you will go and you go to data and you see the managed data model. You can go to the queries and connection here. Something that normally makes look Excel a bit more advanced in what is going on in the Excel part. So that's why I'm trying to show you that thing. Let me show you relationships. Relationships. It's not working right now. No issues. In the next session, if it works, I'll show you in the next session. So this is one thing. We can take up another point meanwhile. Meanwhile, that can be worked. It's not right now working. Another very important thing that I normally use and prefer, that is the Power Query. Very, very popular tool nowadays, and everyone is using Power Query for a number of things. It will take hardly 2-3 minutes to understand. This is the data that I have given you. So E6 data is there. So what you need to do, first of all, you need to extract this data in a folder. So just extract this file. So I'm just extracting the file so that it is there. So now what this file actually has, this file has the data. So this file has a starting data, April and May data. So if you will click here, so you'll find it's a raw text there. So it's a sales data is there, but it is in a notepad file, text file. May data is there, and so on. We have another data. So now normally, what happens, as I was telling you, we normally keep on working on the data, and we keep on getting the data. And at times, when you get a new data, you start working altogether differently. So there is something that is available in Excel that is called Power Query. In fact, you can fetch data from any other source, any other thing. So this is a power, this is a saver function over there. So I'll see how much we can complete in next 2-3 minutes. Otherwise, whatever is left, I'll be starting from the next session. So let us see how much we can cover. So going with this E6 data here. Power Query is something that helps you in importing data from the folders. So normally what happens, we have a, I was working on Excel for long duration, but for years I've done that. What I used to do, I used to get data and I used to copy paste the data like that. So what Power Query does, this is the illustration of that. So there might be some bad data. You can convert that bad data to clean data, and then clean data can be used to give you some kind of information. That is what analytics actually do. So let me just show you how does it work. If I go to the insert, like directly go to the data, and I'm trying to get the data, and I'm trying to get the data from folder. So I'm just selecting from file, from folder. So this is the folder from where I want to fetch the data. So I'm just clicking here, and at desktop, I have the data with me. So this is the path I know where I've saved my data. So this is the initial starting file. So I'm just selecting that start folder here where my data is lying. So I just specified the folder over there where my data is lying. Now what it is going to do, it is going to read out the files in that folder. Whatever files are there in that folder, it is trying to read out, and it is going to give you that particular data. So now you want to combine the data, and you want to combine and transform the data. So this query function will start loading, and what they have done, they have converted that file into a CSV file, and they have by default, you will see what they have done, that was a a notepad data, and the data was tab delimited, and it has already understood by default without even telling that it is a tab delimited data. It could have been CSV data, comma separated value data as well. So then also it would have understood. Otherwise, you can tell. Obviously, you have that freedom to tell. So what you are doing, you are just clicking OK now. Now, what happens here? Just 1 minute job is left, and it is a wonderful tool that you will obviously appreciate for. So now you will see this data is there, and this data is there. Now you can obviously play with the data. You can customize lot many things over there. Whatever you'll do, things will come there. You want to change the format, you can change the format. A lot many stuff is there, so that you can do. I'm not doing nothing like that. Close and load. Close and load. Now what happens here? This data is automatically converted into a table. So data was in notepad data, and now it has been converted into a table. Now what is to be done? You just see the magic here. I'm going to the folder where we are working, and I'm just cutting this file and pasting these files in the start folder. So the new file, new data is coming in my folder now, and just quickly go back to your data. And what you need to do, 365 rows are there. You just need to click here, and you can click here and refresh. And what it will do, it will search the data in the same folder. Now you see from 365, the data has been 481. So on a single click, whenever you enter the data in that folder, this will automatically, will update. And even if you want to change the format and other things, that formatting you cannot, you need not to do it again and again. Once you have to do it, and the same format data will be transformed automatically. This is the beauty of Power Query function. So that's it for the now. 3:29 is there, and 3:30 was the scheduled time for this session. So we have discussed few things, whatever we could in that short span. So if you have any query, you can take up. Otherwise, we'll continue the next session.
Thank you very much, sir. And from 3:45 again, we will meet with Ankit sir for the second session. So thank you very much for this insightful session and discussion on the aspects of Excel. So participants, we will meet again with Ankit sir from 3:45 p.m. in the same session. Thank you. So welcome back, participants again. I would like to hand over the second session to our eminent resource person, Dr. Saxon. So please.
Thank you, sir. Thank you again. So, yeah. So by now, we quickly discussed in the last few minutes. We talked about VLOOKUP function. We talked about mixed cell referencing. That's a Sevo tool. Table function. We saw how quickly that helps. We talked about pivot table. In pivot table, we talked about slicer timelines, and even we talked about building relationship in the data, and making pivot from 3 different table altogether without having common data. Without making one common table, and then only we were able to make pivot from 3 different tables. In the end, I briefly talked about the Power Query function. Important thing that I didn't do in that exercise, you can try on your own. The data sheet is there, data is with you. What you can try on that for data, that if you will change the format, that format will also remain there. So it is really a great thing when you are having one common data. For example, you are getting reports of any particular similar nature again and again. So what you need to do, you just need to place those reports in one common folder, and this master file will fetch the data from that particular folder. So that's something that we could do. I'll just take 5-10 more minutes, and then we'll talk about the research part, which we can be doing with the help of Excel only. Though I've seen the schedule of yours, so there have been heavy topics along with that. But yes, we should not discount even Excel, because sometimes the beauty of the Excel is that it is there in every laptop. The problem with the advanced softwares like SPSS or whatever software you're using for the analysis, sometimes you may not have the version available with yourself, and obviously cracked version have their own limitation, and we should not definitely be using them. So if we are using something like that nature, obviously we might not be comfortable. Everyone may not be good at freewares like R and Python. For R, you don't need any subscription fee or license fees to be paid. It's a freeware, but it is a bit complicated thing. So I work a lot on R. So it's something that, though, let me tell you one thing, because I'm talking about R. So those who know me personally, they know that I'm a commerce graduate, and I've never done in my life any kind of coding or programming whatsoever. So in that case, it is very, very important to understand that it is doable. Even a commerce graduate is working on the R, so this programming can be done. So that's something that I want to do. I'll just take a 30-second break, just a 30-second break. So yeah, so what I was saying, that people have misconception that our Python are for programmers only. It's really not like that. I learned it on my own in few months. So the only thing is practice, perseverance. You keep on practice, you can learn that particular software as well. So moving forward, one more thing that I normally believe that everyone must at least have an idea that it is doable in Excel. So I'll quickly show you that thing, and then we'll move to the research that we can actually do in the limited things that are available in the Excel. Obviously, we cannot perform advanced structural equation modeling kind of things, but yeah, we can do a lot many things over there. Simple basic researches, especially for students, that those who are working on some basic projects, they can definitely use Excel for that particular purpose. So this is one thing that I want to explain you. Let me just take one simple example here. I guess investment will make more sense. Let us quickly do that. Suppose this is the investment data, some very simple thing that we normally, technically I'm a man of finance, so I love talking about numbers and investment. So if you're putting an annuity value of 4,000 rupees, so if you're going for 4,000 rupees annuity you're putting up, you can put any value like that. You can have 5,000 rupees a monthly SIP or whatever. You are expecting that you will be earning 11%, 12% return. So I'm putting it 11% here. Every individual will have different time frame to invest. So let's say we are having 25 years to invest, and here we have done a bit of data validation. We have used annually, half yearly, and quarterly, monthly kind of things. So what we have done, I've applied some VLOOKUP function here. So automatically you'll see when I'm talking about annually, half yearly, so this value is also automatically changing altogether. So let me just make a fresh sheet here so that you'll understand what we are doing here. So let me say the annuity value is 5,000. I'm investing 5,000 rupees per month. So this is I'm investing 5,000 rupees per month. Duration that I want to go for investing is 25 years. So I want to invest 25 years for. And the rate that I'm expecting in the market in my mutual fund category or whatever that portfolio I've made is around 11%. So I want to earn 11% per annum. My rate of return expectation is. So if I want to calculate future value, so I want to say what is my future value, where I'll end up, what will be my corpus value. So definitely you can calculate that using simple FV function. So FV, the rate of return is 11%. And because I'm investing monthly, it has to be divided by 12. So I'm dividing it by 12. Number of years, that is 25. 25 years. 25 years multiplied by 12. So that goes 25 multiplied by 12. Comma, payment, how much payment you are making, payment based annuity payment here. So that is minus, because it's an outflow, 5,000 rupees per month I'm actually paying. So this money, after 25 years will eventually become a good value. This is 78,80,000 rupees, something like it that becomes. So let me remove paisa. When we are talking about legs, that doesn't make sense. So 78 lakh rupees of the money that will be accumulating with this particular investment vehicle for next 25 years. Now, sometime people might be interested in knowing what if I invest for 10 years? What if I invest for 20 years? What if I invest for 30 years? What if I invest for 35 years, or even if I'm investing for 40 years? Some people, in my class laugh, but I say that I'm planning for retirement of my daughter. She's just one is 7-8 years old, and the second one is 3 years old, and I'm planning for both of their retirement. And people get strange reaction to that, and they say, why you're doing that? But see, what the point is, the compounding is the eighth wonder, as we say, and the compounding will eventually be working the longer time you give to your funds. Because ultimately, one important thing, let me just explain you this small thing here. How much is your total investment? What is your total investment that you're putting up here? You are putting up how much value of investment here? You are putting up 5,000 rupees per month, and you're putting it up for 25 years. So you're putting up total 15 lakh rupees here. So your total money that you are putting up into this particular investment is 15 lakh rupees. And if I ask you, what is your future value to investment ratio? And obviously the money that I have paid and the money that I'm going to receive, what is the ratio of that value? So it is going to be this divided by this. So 5.25 is the value that I'm going to get. And let me just show you, I'm carrying 5,000 rupees SIP for my daughter. And if I say she's 7 years from at now, and let's say if I'm starting that investment today, and her retirement will come after 53 years from now. So if I just make it 53 years, you just look at the number. The investment will be of 31,80,000 rupees. And if this rate persists for 53 years, that's a subjective thing. But however, let us continue with that notion. It is going to be 56 times. Let's say the rate might not be that great all the way, but still the amount that you're going to invest, if it is 9% in the long run, then also you'll be having 24 times of your investment value as your future value. So this is something that we normally plan. So now, yes, please ask. Okay. Yes, sir. This is the power of compounding, and that's where Indian investors have one basic mistake that every one of us commits. Even after knowing that, even after knowing that, I interact with some of my finance professors. Even after knowing that, they probably fail to do it. Knowing that the money that will stay in the market for longer duration, will give them more returns, more chances of returns. Still, they fail to do it. That is where this concept is very, very important. Now let us understand what I'm trying to make you understand in this example here. So if I want to make some scenarios and see how does it go. So let me just go to the data part once again. I'm going to the data. I'm going to the scenario, and in scenario I'm adding some scenario. So this is a hypothetical scenario. This is a scenario for, let's say, a very, very vague financial plan that I'm making for my daughter's retirement, right? So this is like that way. And so we are talking about that thing. And here what's happening, 53 years at 9%. 53 years and 9% is the return that we are talking about. So 53 years and 9%. So in short, you can actually remove this narration here. So you can just say, okay, 53 years, 9%, how does it shape? So now it is asking you, so I just didn't specify the things here. So let me just 53 years at 9%. And what change you want, what cells you'll be changing? You'll be changing these cells, B and C, 2 to 4 columns. So this is okay. Okay, and this is your first scenario is added. You just close the scenario now. Now let's be practical and let's talk about ourselves. Let me focus on my thing. I'm starting one investment from now, and I have up to retirement. I have 24 years, 23 years left. So I'm going with 23 years, and I'm expecting my returns will be 12%. My past return have been around that value, so I'll go with that value. So what I'll do, I'll just edit few values, and now I want to add this in my scenario analysis. So in project management and different managerial domains, you must have talked about this scenario analysis, and this is available in the Excel for that particular part. So we are going again in the data, go to the what if analysis, go to the scenario manager, and now again add the scenario. This time we are going for 23 years, and our rate of return expectation is 12%. And let us click OK, and nothing to do, just click OK and close. Some people might be, hesitant not to go with 12% kind of return. They'll say, no, I'll be putting my money safe. I'll not be putting my money beyond bank deposits. So I'll be putting my money in bank deposits. So at 5%, I'll be happy. And nothing else is all okay. I'll be doing with this kind of stuff. So let me just again go to the data, what if analysis, scenario manager, and this time adding another scenario, 23 years at 5%. So I'm even not looking at the values right now. You might be noticing I'm just creating scenarios and feeding scenarios in my scenario table. One last scenario. I normally advise the young chaps that we teach, and I normally motivate them to start investing from day one in my name with a promise that I'll not claim it. So if they have, they are starting with 35 years of investment horizon, and at that age, they can actually afford to take some kind of risk. And if they say, okay, we'll be going with the 12% kind of return, or maybe they might expect something, they are very optimistic at that age. So they might say that we'll be getting 13% return. So that's okay, that's very fine. And let us add this also into the scenario manager. So adding another scenario with 35 years for 13%. Okay. Now you must have noticed I was not doing anything. I was not even reading out the numbers here, nothing I was doing. But I want to now go back and analyze all the scenarios, what I have been talking about, what I've been saving. So now Excel will allow me to do that. So what I need to do, I need to go back to the scenario manager. And you see, we have all the list of scenarios listed here. So the moment I want to see one scenario, 23 years, 5%, I can click here, the numbers will come. I can click to any scenario, the numbers will pop up, and this is going to work. This is one way. We can make a scenario final, report as well. So let me make a report summary. What I want in this result, I want result of these, three values. What will be my future value? What will be my total investment out of my pocket? And what will be my future value to investment ratio? What I normally say, sometimes, I was taking a session, financial planning of non-finance people, and they were like, sir, this is the subject that we have never been, studying. And I normally say money is something that you need not to study. You need to just have that mind that is oriented towards money. And I guess everyone has it. So uh, that much of mathematics everyone understands. The only thing I know, maybe applying a formula that they might not be aware of. So that's where that much of thing can be learned today very easily. So the moment I click here and you see one good analysis we are finding, the 53 years hypothetical scenario that I talked about was 9% return. It is giving me 24 times of the investment to future value thing. So if I'll be putting up 31 lakh 80,000 rupees, at the end I'm expecting a huge corpus of 7.65 crores. If I'm going with the very conservative thing at 5%, I'll be putting up 30 lakh 80,000. I'll end up with only 25 lakh rupees. My future value to investment ratio will be just 1.87. If I will be going with 12%, something like mutual fund or some that kind of investment where I'm getting 12% return. So I'll be putting up 30 lakh 80,000, but I'll end up with 72 lakh something. So this will become 5.28 times. So this is going to be another important part. Now, if I go about talk about the new chap that I was talking, the young person who is 25 years of age and may extend their investment for 35 years easily. So if they are putting up 5,000 rupees every month for 35 years and 13%, they'll be also getting 20 times of their investment. The point to understand here is, here we have taken 9%, here we are taking 13%. Okay, Tejal, I'll definitely show you that how to see the scenarios altogether once again. I'll definitely tell you that. I'm just deleting this. So what we were doing, I hope you got that the process of saving the scenarios again and again that I was doing. I'll just show you that scenario once again. If I'm planning for myself or someone who's having 25 years of horizon for investment till retirement, so 25 years, 5,000 rupees monthly SIP we are talking about, and I'm expecting a return of let's say 11% this time. So that is how the scenario is built, changing few inputs in the table. Go to what if analysis, go to scenario manager, go to add scenario manager. And here we are talking about 25 years, 11%, and click on OK. So the moment you click on OK, this is added in the scenario. Now the summary that I want to get, what I need to do, I need to go back to the scenario manager, click on the summary. In summary, I want summary, scenario summary. You have to tell the result cell. What result do you want to see? You want to see only future value? You want to see only investment value? You want to see only FB investment ratio, or you want all three together? So I'm going with all three together and click OK. By default, it has saved everything into the system. We need not to focus on this current value. It is one of the scenario. And you can now have this complete scenario picture with you. So sometime, when we are explaining someone that, power of compounding actually works. So that's how this this is very, very useful in tool of explaining that, okay, if you're going by this notion, you can have different scenarios, and this can be applied anywhere. This can be applied to anything, any number, which is based on certain formula, right? So this is one thing. One more thing that I normally...
Sir,
yes,
good afternoon, sir.
Yes,
the printout which is coming, the output which is coming in a beautiful color. Can we change the color also, sir? Instead of purple, can we change it, or it is by default?
It is by default, but definitely you can copy and you can take it to the another sheet there, and then you can actually make it a table, and you can insert your own layouts. The formatting you can always play with. So that's always doable. So you can convert this into another table here, and then you can moderate the color scheme and like that.
So the output is very as if it is a printed version from a book. It is like that. Wonderful,
So
sir.
You can play with that thing, so that you can customize according to your wish. That is
Okay,
doable.
sir.
Thank you.
Sir, I have one query, Dr.
Yes, please go
Sumita.
ahead.
Sir, in the formula, we are taking minus C2. That is the amount that we are investing. That is taken as minus. So what is the
Right.
specific reason for that?
See, you need to understand, this is the SIP amount that I'm talking about, the SIP value that I'm investing. So when I say
Right.
SIP or any investment, that is an outflow. So if you're not going to put any sign here, negative sign here, so the answer will come negative. And
Okay, got it.
so this formula is reading that way. Okay, you are getting 5,000 rupees every month. So what you'll be paying? So that's how it starts reading. But in this case, we are paying 5,000 every month, and we want to calculate what we'll be getting. So that's why we put that sign there. Technically, this is an inflow, and this is an outflow. So the outflow should be put as negative in Excel, right? That is the concept. This was an outflow. That was the logic.
Yes, sir,
Another
got it.
thing, thank you. Another thing that I can do here, a lot many things can be done with the Excel, and lot many stuff can be done. So let's say if I want to make a table, and I want to see and explain the students how can you play with the power of compounding. How can you actually build upon this power of compounding for different duration and different years. So let's say if I'm taking years here, if I say let me start with 10, 15, 20, I'm just deliberately not taking difference of 1 year, because that would be very lengthy table, though Excel will not mind. Excel is a very obedient friend of ours, so he will not deny, but still, why to trouble our eyes right now? So I'm going with the 10 to 50 years of horizon here. And let us take the duration. Minimum investment I expect should be around 5% return, and maximum logically, should not be stretched more than 12%, to be honest, if you're talking about that long horizon. But let me keep it up to 15%. So what I've done, I have taken duration rate here. I've taken rate here. This is rate at which I want to invest. This is the duration for which I want to invest. So this is the values that I have hypothetically. I've just created these values. So I'm just giving it a name so that you can understand what I've done here. So this is the duration of investment. So this is the duration of investment, and let me just rotate it this way. So this looks clear. And here we are talking about the interest rates that are available. So we are talking about the interest rates that are there. So probable interest rate that one person can actually earn. So he might earn 5%, 10%, 12%, depending on his risk appetite. So this is the investment rate of return. So this is one thing that we have built now. So let me just give it some shading here. So that's like that. And this is the duration part. So we have duration, we have returns. Now, if I want to see one thing, how does power of compounding work, and why we should invest for longer duration? Why should we look for some decent rate of return in our investment? I'm taking this future value to investment ratio. You can take any value. You can take and make this table with any value. I'm taking this future value to investment number here. Now, this is important. Why I've done this? This is the junction cell that I've used, and I've taken one particular value, 5.25 here. And this 5.25 I put at the junction, where the interaction is going to take place. So what I'm trying to tell Excel, please calculate this junction value for all possible combination. So if you're going to do it manually, it is going to take a lot of time. And in Excel, we have some quick functions for that. So let me just use that quick function here.
Sir, what is the concept of this junction value of 5.25? What is the significance of this, sir?
See, at 25 years, at 11%. At 25 years, this 25 years, at 11%. My answer should be 5.25. Right?
Okay,
But
sir.
I
You mean to say average return?
My future value to investment ratio.
Okay, sir.
The future value that I'll get and the investment that I'll put, the ratio of that particular amount will be 5.25 times.
Whatever is irrespective of the time horizon.
Yes.
Okay,
Whatever is going to be, see, I'm investing 15 lakh and I'm getting 78 lakhs. So that is 5.25 times.
Okay.
Of my investment.
Okay.
So I'll be getting 5.25 times of my total investment if I invest for 25 years at 11%. Now, I don't know about other combination. All these other combinations are not known to me. I don't know what these values are going to be, except one value. I know only this particular value. And I want Excel to calculate all these values for me. And there are like 9 into 11, 99 values I want to calculate. And this could be 9,000 values. That really doesn't matter. So how do we calculate this? We need to select the table. We need to select the table. Make sure that you're selecting from the junction cell to the last table cell over there. Make sure that selection should be right. Otherwise, this function will not work. Select the entire cell like that. And then you go to the data. In data, you go to what if analysis and data table. And now there's a trick. What you have put in the row, we have taken row the rate of return, and the 5.25 that we have calculated, we have calculated that value from where? We have calculated that value from these inputs, and the return is where? Return is here. So in the row, what I'm going to change? My rate of return, and the rate of return originally is where? In C4. So I'm mentioning C4 there. Now, what is there in my column, F column in this table? F column is having the values of duration, and duration originally I have taken in C3. So I'm changing C3 there. So I'm telling system, please change C3 value to 10, 15, 20, 25, and so on. And I'm at the same time telling the Excel, please change the value of return that is already there in C4 to 5, 6, 7, and so on up to 15%. And click OK. And the moment you'll see that this is calculated, and let us make it a bit readable, just putting simple decimal points. People worry. People say that we were investing at 5%. We invested at for 10 years, 15 years, 20 years. Frankly speaking, now this is not the duration at which your compounding will show you any significant result. If you are investing for 25 years at 5%, whatever you'll invest 10 lakh rupees, eventually through this SIP, your total corpus value will not be more than 2 times of it. So at 5%, it is difficult to grow your wealth. Obviously, we understand that. So if you don't have risk appetite and if you are happy with that lesser, wealth creation, that is where you have to compromise. For someone who is going at 12%, you just see that comparison. The person who is, the person who is going at 5% only in bank FD for 30 years with the same SIP, he will be accumulating how much? 2.31 times of the investment value. And the person who is going with 12%, and if he gets that 12% for 30 years on an average, he will be ending up with 9 times of the total investment value. And let us see value if this continues. I wish this continues for the fund that I was talking about. It will be 65 times. So the longer you stay in the market with your capital, the money will start working for money. Warren Buffett always says that you don't work for money, let money work for you. And this is how money works for you. So you need to give your money a time to accumulate returns on returns, compounding returns. And that is where, the time is the key factor. First 10, 20 years, at whatever rate, nothing is very fancy. Even, the person who is investing at 12% at 20 years will not have much good, values to enjoy. But if he could have, increased his time by 10 years, 1.5 times, his future value to investment would have been 2.25 times. So that's the magic of compounding. And if you could have started, for more 5 years, the value you see is technically going close to 400%. Yes, Sunita ma'am, yes, please.
Sir, my only query is how come, how just by selecting the whole table from the junction cell, the Excel knows that, we have to create this?
This is the data table. This is technically the what if analysis. What if the rate is taken to be 5% and the duration is taken to be 15 years? So this is the combination that Excel, has this programming done for. So in this particular function of data table, what we are telling Excel, we are giving multiple values in the column rows. We are giving multiple values in the column, and we could have made even a bigger, wider table. So Excel will definitely, replace the values. So it replaces the value in the original. Originally the value was taken 25. Now what Excel has done, in space of 25, they have gone for 10, 15 and all the values for all these calculations. So
Okay,
yes,
so
it's
this
a
is
part of-
the programming that is already done. So, and we are just making use of the programming. So let's say
that's
if in the junction cell, if we would have put future value, then here we, in the data table, the
I'll show
future
you that.
value
If-
would have been
Yes,
propagated.
if I'll connect the future values there, the only problem with the future value is it's a big number, so it will not fit
Yeah.
in the cell. So I'm just keeping it 1 rupee per month, just to make it visible here, because
Yeah.
future value is a bigger number. So let me just do that. So that's how, yes, if we are converting future value here, 1 rupee 25 years at 11% will make 1576. So what will be the value of 1 rupees of SIP at 14% after 30 years? So I get that answer here. And then I can multiply.
Okay,
So
so thank you so much.
what-
Interesting.
Whatever we are going to put in the junction cell, the Excel is going to calculate the same thing for all the possible combination of these rows and columns that we are specifying.
So this junction value has to be kept in junction cell as well as in the corresponding.
Yes, this is
cells
already
also?
there. See, this is there are three things which are very important in Excel. One is what we call assumption or input. So this first part, which I'm highlighting as yellow one, is my input. This second part, which I'm highlighting right now as green, let me highlight it as blue, is my output. And what I'm doing here, I'm not typing this value. You must have noticed I'm referencing, I'm referring this cell to the output cell. Sometime people type this 1576 and nothing will happen.
Okay.
All the values will get constant.
Okay. So you are basically importing the formula.
Yes, I'm
from-
referring the value from the output in this
Okay.
junction cell.
Okay. So you are
Then only
basically
Excel will
importing the
understand.
formula from the output table to junction cell.
Right, and that is the
Okay.
junction cell formula is now been spread out to the entire table.
Oh, that's the beauty. Thank you.
Right. So this was something important. We normally use this multiple times in the data analytics as well. So when multiple values that you want to create for multiple possible pair of combination, that we can do like that. Right. So this is one thing I wish to share. So let's keep this much, and let us the topic of this session is about research methods that are available in the Excel. We'll quickly see that, and if you are not having any access to any software for time being, and if you want to do some kind of basic analysis and you're stuck, then you can rely on the Excel too. Though there are many floating softwares which are available, but still Excel has some basic utilities which are available in the Excel itself for the data analysis part. So we can apply basic t-test, regression, correlation, ANOVAs with two-factor, one-factor, everything like that is available. With replication, without replication is available. So basic things that initially, a novice researcher starts with are available in the Excel too, and I'm sure most of you must be familiar with. It's a refresher course also, so sometimes it's good to refresh what we already know. So I believe this Excel part, whatever I've discussed, a few things would have been definitely some use for you. So just closing this right now, and right. So let us start with R1 straight away. There are 4 files that I've kept, not deliberately much I have kept here. We'll talk about regression. I'll give you a brief idea about correlation and few basic parametric tests which are available in this Excel 10. Very first thing, if you are using Excel for the very first time for data analysis, so you might not find this data analysis, tool active in your MS Excel. So if it is a case, I'm using 2019 version. In the older version, you will see one Microsoft button at the left corner of this, Excel. You click there, and there also you'll get one option called Excel option. So click on the Microsoft button if you're using older version. Otherwise, in the newer version, 16 onward, you might find this file option there. Go to file option and then go to option. So in older version, you have to click on the Microsoft button and then go to the Excel options, which is available at the bottom of that drop down. So click on the options here. This will pop up like this. Themes, I've taken some dark theme right now, so that is okay. You can customize that as well later on. So you need to go to the add-ins. Go to the add-ins, and in add-in, this is going to be similar interface that you'll be seeing even in the older versions of your Excel. Go to the add-ins. In add-ins, you have this Excel add-ins, which are available there. So you can click on this Excel add-ins here, and this will pop up the things, and where you will have this analysis tool pack, another lot many things that you want to use. There are a lot many add-ins which are available. You can even install some more add-ins which are available, which do a lot of specific tasks which are not normally available in the Excel as of now. So, well, I'm talking about the analysis toolpack, which is already available, and you just need to click check on this and click OK. The moment you'll do that, you'll find in data tab this data analysis and solver. I've already also checked on the solver, so this two have popped up now. So this must be available to continue with any kind of analysis in the Excel, very first thing. Thank you, Sadhvir, for that word of appreciation. So in this case, we are going with the data analysis here, and data analysis is active now. Let me just quickly show you what we can do in the data analysis in the Excel. So if you start from the beginning, they have sorted it by alphabetically. So nothing like which tool is more important and something like that. They have sorted it alphabetically. So first thing is ANOVA. A single factor ANOVA can be applied. Two factor ANOVA with replication, without replication can be applied. Correlation, covariance, basic descriptive statistics is there. Someone who's working on the forecasting, exponential smoothing can be done. If you want to apply F test for checking the significance of two samples variance, that can be done. Fourier analysis is there, so that is one different way of forming data. Histograms, moving average. We can create random numbers. That's something very, very useful exercise. If you want to show, prepare one data set for the students, and you want to create some random numbers, so that is a very, very handy exercise that you can have. Then we have t-test available there, regressions available there. Sampling works pretty well. I'll tell you how to work with the sampling here. So these are some basic things which are available in the Excel. So not having access to any big software, this is a savior. If something is to be done and you cannot have the other software, so this is something that you obviously can help you. So let us start with the one sample t-test. Obviously, by now, I'm very much sure that those who have been attending the program, so the process of the hypothesis testing has been explained. Just to keep it very simple, whenever we have any kind of problem, we start with the hypothesis. We have to have, basically a null hypothesis, which suggests that whatever we are measuring is not significantly, there. So we are saying that difference is significant. The null hypothesis will say, no, there is no significant difference. That's how we normally frame it. We will have the alternate hypothesis, which will say that, no, it is significantly, there. The difference is significant, the relationship is significant, the dependency is significant, whatever we are trying and measure. So when we say nothing, difference is not there and it's not significant, it is null. When we say it is significantly there, so we will call it alternate, right? So we frame that thing, we specify our level of significance, alpha, that you normally call alpha. So that alpha is specified, and if not specified, normally it is taken to be 0.05. So that means simply that whatever hypothesis testing you're going to do at the end, you'll be making interpretation. Out of 100 times, 5 times you might be at the wrong end. So 95% confidence is there. Whatever interpretation you're going to make is going to be correct. So there's only 5% error chances there. So that is level of significance. You can moderate this value as per your requirement. Then we apply the test. Whatever test we are going to apply, we may apply a number of parametric, non-parametric tests here, according to the nature of the data. According to the nature of the data, that's very, very, very important thing to understand which data will be there. Prabha, which thing you want me to explain again? I just saw your message at 4:21. So I don't know where, at which point I was there in that time. So if you can specify that topic, I'll again reiterate the same thing. You can just, okay, you got it. That's great. Thank you so much. I just forgot to see the message. at that time. So the third thing is we are going to apply the test. Every test has their own statistic. So we will get one test value. So when we are applying t test, we'll get t value. When we apply f test, we get f value. And obviously every test has their own values. Finally, we make interpretation. So whatever output we are going to get, we will be making certain interpretations out of it. And interpretation has a very simple thumb rule that if your p value that you have received is more than 0.05, the alpha level of significance here. So if your p value is more than level of significance, which is in general 0.05. I'm not saying always, but in general it is 0.05. That means, which means that this means that null hypothesis is going to be accepted. So we normally say we don't have enough statistical evidence to reject null hypothesis, and it goes vice versa. So if we get p value which is less than 0.05, so then in that case, H naught will be rejected. And obviously, when we are accepting or rejecting one hypothesis, the counter hypothesis definitely gets the opposite treatment. So when I'm saying H naught is rejected here, that means H1 will be accepted, right? So this is the basic premise of hypothesis testing. I'm sure everyone knows it. So in that case, let us quickly do some quick test and see how does Excel perform all these things. Let me go to the data analysis. See, if you want to see here, what is the data we are talking about here? The data is of GDP growth rate, and GDP growth rate data is there, and government is claiming that GDP growth rate is significantly higher than 5.5. So it is more than significantly more than 5.5%. That's what government is claiming. Now, when I'm saying more than 5.5, I'm talking about one-tail testing here, right? So I'll explain you what is this two-tail and one-tail. I'm sure you must be knowing, but just to make sure that no one is left in that learning process, so I'll be reiterating the fact here. But before doing that, if you notice here, we want to apply t-test here, one sample t-test, because we have got GDP growth rate, and we want to compare this GDP growth rate with one hypothesized value, which is 5.5. Now the problem with this thing is that we don't have one sample t-test in this Excel. So what I have done, if you see, I've created a second dummy variable. I have taken the claim value here. So this is the claim value of the government. Government is claiming, and I'm comparing this 5.5 value against all the possible things. You need to understand how the tests are going to work. I normally say, people focus on the learning of the SPSS, different softwares. That's always good. You must do that. But if somehow, I'm not saying you must know the entire way of calculating t value, but at least if you know how the t test is applied and what they normally do, that will solve your purpose. What is t test going to do? Let me tell you. T test is going to take the average of the number that you are talking about, that is 6.03, and you want to compare that average with 5.5. So it is going to basically the function of the t. If you remember, that formula is x minus x bar. So you have a value that you want to compare with, and then the average value is there. So you will compare the average value with the claim value. So that is how they are compared with. And so ultimately, if I'm putting 5.5 across this number, it's a dummy series that I've created, and it is going to help me in applying t-test even in the Excel for one sample. Otherwise, it was not possible without using this dummy number here. So that's what we are doing. So let us quickly do that. I'm going to the data analysis. In data analysis now, because I've converted my data, for two samples. Now, there is one thing, those who are technically into research, they know that in t-test, when you are comparing one variable with the other, we first need to see whether the variances are equal or not. Because if the variances are not equal, we should not be comparing two values of different variable. So for that purpose, in SPSS, I hope you must have seen, we apply Levens test. It's a by default output along with the t-test. So Levens test basically gives you the idea whether the variances between the samples that we are comparing are equal or not. So if the variances are equal, then only prima facie, this t-test should be applied, because t-test has this prerequisite that the variances that we are talking about of the two samples should be should not be significantly different. They should be equal. Though even the t-test table will provide you the output for variances equally not assumed row, so that you can read if your variances are not equal. And in that case also, there are evidences where we can apply this particular test. But in ideal situation, if you want to compare two independent variable and you want to say that okay, there's a significant difference, it is advisable that variances of both the samples should be similar. That's what is done. So it is here. Now we are going with we are assuming that right now the variances are equal, and clicking on t-test 2 sample, assuming equal variances. Clicking here. What is the variable 1 range? My variable 1 range is this. I'm selecting the entire range. What is the variable 2? The claim value government is claiming for, that is 2 claim value. And because I've selected along with the heading, so I'm putting labels checked. That is important to remember. So we are putting that labels check because we have selected along with the heading here. Now, where do you want your output? You want your output in the same sheet or new workbook that you can specify. Because it's not a big output, I'm taking it here only. I'm just putting the values here. It will be 3 column outputs. I'm just putting it here. If you want to specify alpha, you can specify alpha. You can moderate the alpha to 0.01 to 0.05, anything like that. So 0.05 is by default the level of significance. So that is how you're going. If you want to specify a particular hypothesized mean difference here, that is okay. Otherwise, it is taken as 0. So we are going with 0 here. That is understood. And this is how your output will eventually turn up. And let us quickly understand what is the meaning of this particular output here. The average of GDP growth rate is 6.03. We also calculated the same number. We got this answer earlier. The variance here is 1.41. The observations number is 14. Claim value was 5.5. And because it was constant, there was no standard deviation at all. Observation number is same here. Pooled variance is calculated, and hypothesized mean difference by default is taken as 0. I told you this. I didn't mention this, but it is already taken as 0. Degree of freedom is 26. How we are calculating this? There are 13 numbers here, to be 14 numbers here. So 2 sample n plus n2 minus 2. That is how the degree of freedom is calculated. Well, that really is not of much botheration at all. What we need to focus on the p-value. And that's what we normally do. We got this output and the interpretation will be writing on the basis of p-value. Now, the important part to understand here is which p-value we must be talking about here. We must be talking about two-tail p-value, or we must be talking about the one-tail p-value. So I'll just give you the idea here what was our null hypothesis here. So in this case, the null hypothesis that we made, so the null hypothesis that we were making, I'm just typing it here for your easy understanding. The null hypothesis should have been, there is no significant difference. There is no significant difference between, because we are talking about two numbers here, between the average GDP growth rate, average GDP growth rate and government claim. So first thing is to reject. Very simple thing is whenever someone is saying something, you say no, it doesn't happen. So it really doesn't exist. So the very first thing that we have specified here is that there is no significant difference between the average of GDP growth rate and the government claim. Second thing is government ये कह रहा है कि average growth rate जो है that is more than the 5.5. So they are claiming a number and they are claiming that it is the average growth rate is significantly above that particular number. So here what we can say, what can be the hypothesis, in numbers and in narration. So let me write both ways. So we are saying that average growth rate is significantly higher than the government claim number, and the government claim number is known to us, that is 5.5%. So this number is being claimed by the government, and that is there. So we can actually mathematically say that the average GDP growth rate is greater than 5.5. So that's what the null hypothesis, alternate hypothesis we have made. Now you need to understand, because we have made alternate hypothesis in this way. This is the formation that belongs to one tail test, because here what we are claiming, the average that we are trying to compare is significantly more than. So it is on the one tail we are testing only on the right hand side, that the number that we are claiming, average of that number is more than this number. So it's like it is not less than that number, it is on the higher side, and that's what we want to claim here for. So we are testing only for the one tail. I'll give you one more example for understanding this thing, one tail and two tail. Sometimes, what happens if we are comparing GDP growth rate of India and China, or India or Brazil, or any other, similar nation like that. So we say that, no, there's a significant difference in India and China. So now when I say like that, so I'm opening both the possibilities here. India might be growing faster than China, or China might be growing faster than India, vice versa. Both way, if the difference is significant, none of them is mattering that, okay, who's, which country is having higher growth rate. We will call it two-tail test, because we are comparing two different countries and we are saying different GDP growth rate. So that is where, this is a two-tail test example. But when I say no, I want to prove that my country's GDP growth rate is more than your country's GDP growth rate. So then it is going on the one end. So then it becomes one tail. So I hope that gives you a clear understanding. Another example, we all are teachers, most of us are teachers. So when I go in the class and you go in the class, let's say we both are sharing the same subject. Every teacher has this, supremacy of teaching skills, mania, that I am the world's best teacher. You go in your class, you believe that you are the best teacher. I go in my class, I believe I'm the best teacher. No teacher will fight. We are sensible enough for that thing. But somewhere in the mind, we might be thinking that way. And we might to say that my students have done better than yours. And if it comes, earlier days when the colleges were in the UPTO era, the colleges used to fight for these averages only. Like my college's average is far better than yours and all. So if section average is being compared to see, which section has done well, it might not be having anything to do with the teacher's teaching skills at all. But if section performance is being compared, and if I say that section A has significantly different performance from section B. So I'm not saying section A is better or section B is better. So in this case, it is a two-tail test exam. But when I make a notion, no, section A is a better student, all the good students are there. We have kept all the top rankers in section A, and section B was slightly on the lower ranks. So section A must perform better than section B. So when I'm saying like that, it becomes one-tail test. So I'm explaining with all these examples that how do you identify whether it is a two-tail or one-tail test. Well, in this case, it is a one-tail test. So obviously you must have read somewhere for sure, when we are getting p-value for two-tail test, so then we need to divide it by 2 to get the value for one-tail test. So I'll just tell you, if I divide this value, this particular value divided by 2, I'll get the same value. Let me just, we don't need these many decimal points. Let me just reduce the decimal points for the understanding. We can increase 2 or 3 decimal points. That's good enough. Now, in this case, the p-value is coming out to be 0.051. So what I've done, I've made my hypothesis. I have specified my level of significance. The test name, I know which test I've applied. It is t-test for that significance. The test statistic is the t-value. So t-value is coming out to be 1.698. This is the test value. Here you can see that, this number. So this is the test value that I have received. Now interpretation part. Either of this will happen. Either of this will happen, and obviously you can relate now. The p-value that we have received here, p-value is 0.051, and that is eventually greater than my level of significance. So my level of significance is 0.05. So when I say that, now you can understand what's happening here. So when I say that, it means that what I'm doing, my null hypothesis is being accepted. And when I say my null hypothesis is being accepted, this holds true. This is true. and this is not true. So in spite of that number being bigger, in spite of that number being bigger than the government claim, 6.06 is a bigger, 6.03 is a bigger number than 5.5, but it is not statistically significantly more than 5.5. तो जब तक statistically हमारा कोई भी value significantly difference नहीं लेता है, we cannot claim that it is significantly more than that. So statistics is not supporting that claim right now. Yes, it's a small data. In the bigger data, the things would have been different. So please go through this entire explanation, what I've given you, and if you have any doubt, you can ask. Then we'll move forward to the next things.
So can you explain the last part, sir? This how we are rejecting or accepting the null hypothesis or the other one? How we are comparing this 6.039 with the growth rate of 5.5? I'm clear with everything. Just the last part, the conclusion part.
Right, Pankaj. First of all, very first thing in this set of problem was that because we need to identify where we are going to go. We are going to go to two-tailed t-test or we are going to go one-tailed t-test. First thing. So I explained you with number of examples that it is a case of one tail because we are claiming that our number is bigger than a particular number. So it was going on one tail. Very first thing we identified, okay, it's a case of one tail. So when I say it's a case of one tail, so this two tail numbers becomes irrelevant for me. Very first thing. These two tail numbers are not relevant for me anymore because I'm not going to read them because my problem, my hypothesis in this case is of one tail nature. Very first thing. Second thing, I need to see what is the p-value here. The p-value here, it is 0.051. So the p-value that I've received is 0.051. And I told you this is the formula, this is the thumb rule. We normally have this, applicable in all the tests that we apply across the research methods. So in this case, what's happening? The thumb rule that I've shared with you, if p-value is more than level of significance, which is ideally 0.05 in general. So then what will happen? Then H0 will be accepted. This is the thumb rule. Now you see your p-value is how much? 0.051. And this 0.051 is more than 0.05. So because this number is more than 0.05, then what happens? H0 is accepted. So that means this holds true. So there's no significant difference between the average GDP growth rate and the government claim. So it is not significantly more than the government claim. ठीक है ज़्यादा है, but it's not more than the significantly more than the government claim. I hope that serves the purpose.
Yes, sir. That serves the purpose. Then what is the significance of 5.5 and then 6.039? Why did you do that? This is
the average. This is the average GDP growth rate numbers were there for last 14 quarters here. So for last 14 quarters numbers are there. So what I did, I just saw, okay, what is the average number? Average number is 6.03. So my country is growing GDP 6.039% every quarter. That's one thing. But government is saying that we have been maintaining 5.5 more than 5.5% GDP growth rate for last 3.5 years, 14 quarters. So this claim we were testing, this assumption, this hypothesis we were testing, and this hypothesis tested, and as per the result, if this number, just imagine if this number would have been 0.049, then in that case what we would have said, yes, government is correct and government claim is correct, because then in that case what would have happened, the p-value in that case would have been 0.049 and this number would have been less than the 0.05. Then we would have said H0 is rejected. Then I would have said, yes, government is claiming correct. The average GDP growth rate is actually technically significantly more than 5.5%.
But here, what is happening here? In this case, is the government not claiming right that the average growth rate is more than 5.5? I'm a little confused here, sir.
See, sir, what happens? Let me explain you this thing with some other example. Recently, last 2 years back, when this vaccination drive was happening, and the companies were rushing to claim the efficacy of their vaccination efficiency, right? So Covaxin has a different efficacy rate. Covaxin was claimed to have 60% efficacy. Covishield was claimed to have 65-70% efficacy. Moderna and other Pfizer were claimed to have 85% of efficacy. So they were claiming for their efficacy. Now just understand, two different vaccinations are available in the market, and both are fighting for claiming that they are better vaccination. So my efficacy rate is 60%, your efficacy rate is 62%, and you are claiming that you are better than me. So what I'll claim for, let us test it statistically, whether these numbers are significantly more than or not. One example. Second example, my average percentage are 78%. Your average percentage marks across your academic career was 79.2%. You are boasting of that I'm having more average, academic average throughout my career, and you are having 78, I'm having 79.2. That's fair enough. Both are good, fellows. But can we say that 79.2% is significantly more than 78? Mathematically, it appears like where you're getting confused right now. Mathematically, it looks like 6.0 is more than 5.5. Why we are discussing all this, right? So 79.2% is more than 78%. Why we are discussing that? But we have to, when we are saying yes, it is significantly more than something else, we need to have a statistical evidence for that. And this is where we make hypothesis. We make, we do the testing. And once we get the output, we go and analyze that output here. So that is how, we come to the conclusion, okay, my test, whatever I have applied on this particular data is giving me a value which is not supporting the claim of the government. Though it is more than 5.5, but it is not significantly more than 5.5. Please understand. It is not significantly more than 5.5.
And how did we come to know that it is significantly not more than this? By using
because our null hypothesis is being accepted here. After the entire process, we got the p-value, and the p-value is more than alpha, and when it happens, h0 is accepted. That's
here our p-value is 0.051, right?
0.051,
which is greater than
0.05.
Okay, got it, sir. Got it.
Right. So that is the thumb rule. That is what we follow. And because whatever test you are going to apply, in your life, whatever analysis you are going to do, how complicated things may be, this fundamental premise is not going to leave from any research method.
Yes.
So fundamentally, you must be very sound on these things, and then you can actually read any test, anything like that.
Sure. Good explanation. Thank you.
Thank you. So that is one thing. Let me move to the second part, just closing it. R1 is done. We have around 20 minutes left. So I want to give 5 minutes for question and answer too. So let us move on to the next topic. I'll show you quickly because we have understood the process now. Now things will be easier. For example, there's a R2 file, which is for paired t-test. Now, Satveerji has mentioned for one thing, yes, it's mandatory for everyone, not for only me or you or anyone. It is important to go through some basic elementary book to understand, where which test is going to be applied. And the beauty of such programs, such interaction is that you come to know, I was going through the profiles of the various eminent speakers of the FDPs. So obviously, they are bringing up their experience. They are sharing some basic, advanced tools as well. So where this particular tool can be applied, if you're talking about MCDM, where that MCDM can be applied. If you're talking about structural equation modeling, where that can be applied. If I'm talking about factor cluster discriminant, where that can be applied. Unfortunately, Excel does not support all that. So I won't be stretching beyond the session plan. But yes, you need to understand where this particular test can be applied. That understanding is the most important thing, and then your journey as a researcher becomes easier, and that's really something very important. So now moving to the paired t-test, and before talking about this t-test value here, let me explain where do we apply this. This is one data, and that's talking about before and after intervention values. So some examples that I've mentioned here to save time. For example, if you say that government is saying that after Make in India, the unemployment rate has improved. Okay, so that's where
Sir,
before Make.
can I add one thing?
Yes, please, sir.
I would like to say something to Pankaj Kumar ji. Pankaj ji, Dr. Ankit Saxena is teaching only Excel here. He was our professor for this FDPs as well as for PhD course program.
Okay.
So he is master of everything. In fact,
Yes, sir.
SPSS as well as E-views and all those things. So it is only a sample of Dr. Ankit sir. So whatever he is teaching here, it will be applicable in SPSS also. The same philosophy. So it is better that you go through this CR Kothari. It is a simple and very good book, sir.
Sure, sir. I will. Thank you for the suggestion.
Thank you, sir.
You can even go for the advanced books once you have understanding the basic things. So then you can read multivariate analysis by here and all. So there are some very good books available. So yes, there's no end of learning. I've been striving to learn everything by now, and unfortunately, that when I feel that I've learned this, I come to know that 6 more topics are left to be learned, and then I learn 6 more. Then I come to know 60 more topics are left to be learned. So that's a never-ending journey.
Same feeling every second I have. Every second I have the same feeling. So I can relate.
So that's our life, sir. That's our life, and that's how we learn and we progress and we grow. That's the natural progression towards the excellence, right? So thank you, Satviji, for again sharing your thoughts on that. So this is the research IQ before and after the workshop. This is that kind of data. And one thing Satviji pointed out very nicely, that whatever software you're using, the explanations will vary, the procedure might slightly vary, but ultimately the output will come in the same format. You will have same test statistic, you will have same p-value, and you will have same set of hypothesis. So it is only the cover that you are changing. It's all integrally all the same thing. So if you are using SPSS, E-views or whatever, that is all one and the same thing. So research IQ before and after, if you are going to put, for example, before this FDP and after this FDP, definitely we learn. Having that quest for learning is the most important part of any good academician at any age. So when we are talking about research IQ before the program and research IQ after the program, we normally expect that the research IQ should improve. The value should actually increase. So research IQ after the workshop or any FDP should eventually improve from the research IQ before. Now, please tell me whether it is a two-tail test or it is a one-tail test that I'm talking about as per the hypothesis that I'm making. It is sounding more like a one-tail testing or two-tail testing to you.
One-tail test, sir.
Very good. It is a one-tail test because what I'm claiming for that after attending the FDP, the research IQ eventually should increase. Very right, ma'am. So that is where this value has to increase. If the research IQ goes down after the FDP, then we should stop conducting those kind of FDPs for sure. So that is the very, very essential part here. Now, how do we apply? I was giving some example. Let me just complete that. So if I say Make in India, before that unemployment rate, I want to compare with unemployment rate after that particular program. That is a peer t-test example. Sometimes, marketing people talk about advertisement. So they say before the advertisement, the sales were down, and after the advertisement, sales have picked. So they want to claim that advertisement campaign was effective. Efficacy of the vaccination we have been talking about. So we got vaccinated, we survived. So those who survived, they were obviously happy. So the efficacy of the vaccination was being talked about. So those who did not get vaccination, how many of them survived, and those who got vaccinated, how much of them survived. After getting vaccination, what changes were there in the immunity and all those stuff. So that is all can be covered in the priority test. So when we talk about before training performance and after training performance in HR, that is an example of priority test. So there are a number of examples in different contexts which invite the understanding of priority test. Now, if I'm talking about peer t-test, so this is the explanation that I have given you. Now, if I'm talking about the application of peer t-test, I want to apply peer t-test and see whether, what's happening here. So let us quickly go to the data and go to data analysis once again. And in this case, we'll be using paired t-test. So paired t-test, paired two samples. So I'm going with paired test here. So now what I'll be doing, I'll be selecting after research IQ, research IQ after the FDP and before the program research IQ. And because if you noticed, I've selected along with the label, I need to check on the labels here. I need to check on the labels here. And output you can take here only because again 3/4 column output is going to be there. So I'm selecting the output range in this sheet only. You can go to the new sheet and new workbook as per your requirement. Clicking OK here. And just dragging the values here and reading out the numbers. Such big decimal points are not making any significance. So let me just make this table relatively easy to eyes. So now we have got something to understand. After research, after program, the IQ has improved. It is 62.45 on a scale of 100. Before the program, it was claimed to be, it was measured to be 56.7. So there has been a difference. So the research IQ has increased by 5.75, during the FDP or the program that was delivered. They are talking about the variance, they are talking about the observation, they are talking about the correlation as well. So correlation has to be there because it should not happen that things have become very dramatically changing, like the person who was very weak and suddenly has become Einstein and the Einstein has become very weak. So that should not happen here. So the correlation, high correlation justifies that, okay, this paired correlation is working. Yes, Satbiji, you are right in your explanation. Let me just come to that. We will not be reading this. We will not be reading two-tailed part because our hypothesis that we framed was of one-tailed nature. So we'll be focusing on this value here. That is 0.023. 0.023. And now remember, so we are saying that p-value that we have got, the p-value is 0.023, and this is less than level of significance. So this is level of significance value, which is less than that, and this is 0.05. So in this case, because the p-value is less, so now I understand, as Satbiji has written, that H0 is going to be rejected. So this is going to be rejected, and when I say H0 is being rejected, that means H0. What should have been the H0? H0 was that there is no significant difference in research IQ before and after the program. And H1 would have been that research IQ after the workshop is significantly more than. This is how the H1 will be framed. I'm just typing it here. H1 will be research IQ after the program is significantly more than research IQ before the program. So yes, and that's how you will place this particular thing, and you'll say yes, it holds true. So paired t-test has been applied and output has been received. So this is paired t-test. Let me just quickly talk about regression also. One more tool here so that we can find a that thing as well. So I'm going with the R3 sample data. This is this data sample data that will be opening in a while is basically a summary of questionnaires data. So it is the data that has been retrieved from one questionnaire. So now in this questionnaire there was small just to give a demo experience, this data is being used. This is how the data looks like. So there's gender given, there's age given, there is income given here, and the A1, A2, A3, there were three variable, that were asked for one A factor. B1, B2, B3 were three questions that were asked for B. C1, C2, C3, three questions were asked for C variable factor. So there were three factors in the study. There were three questions each, not a practical thing. This is just a demo data, just to make few things clear. Normally, what we do, even in the Excel, when we take up this, when we enter the individual response that we are getting, what we normally end up doing there, we normally take average of In SPSS, we transform the data. We transform the variable, we compute the factor score there. So individual variables are having no, significance in the analysis, to be frank, not much, except the factor analysis and CFA. So then what we are doing, we are going to work path analysis or something like a model that we want to work, regression we want to apply. We cannot apply regression on individual variable. So we will be applying regression on the factors straight away, so that will make sense. Individual variable regressions will be too complicated to read and make sense out of it. So what we normally do, even in the spaces, we summate and we average the variable to get the factor score. So same thing we are doing here. So A1, A2, A3, whatever question we asked for A, we are taking average of that number. So that gives me 5.33. So on a scale of 1 to 7, this data has been collected. So 6, 6, 4, that means total is 16, 16 divided by 3, that gives you 5.33. Similarly, we can calculate average for B1, B2, B3, that is 555, and that gives me the number 5. So that is 5. And then average and C1, C2, C3, be very careful with your selection, C1, C2, C3, and that is your average number there. So what we are getting here, we are getting average values of individual components. So that's there. And we can ignore this error because Excel is confused that why you are skipping 3 numbers for taking an average. So that is ignorable error. So I ignored that error. Save this file. Now, let's see, I want to apply a regression here and I want to say that C is a function of A and B. So C is a function of A and B here. So I want to calculate the regression equation for the same. I want to see whether the C is significantly, depending on A and B. Can I make a prediction model using A and B as IV and C being the dependent variable? So can I make some equation like that? C is equal to A plus B1, A plus B2, B. Can I make some equation like that? So that is what I'm trying to assess for. So let us do that. How will we make the regression analysis here? So go to the data, go to data analysis, and in data analysis, you can go to the regression part here. So the moment you click here, it will ask you what you want to select as Y and X. So dependent variable is Y. So that is C. I've selected along with the label. So that is selected. Now input X, that is A and B here. And I'm selecting labels also because I have selected A, B, C along with the data. So that is very important to remember when you are selecting along with the label, when you're selecting along with the headings. So please make sure that you're selecting on the labels because the first row will be read as label because it's not a number. It cannot be used for any statistical analysis. Do you want some kind of line fit plots? Do you want to have some kind of residual plots that always, works in advanced analysis that you can try? You can see the residual part. You can see the standardized residual part, which can normally be extended for further analysis. Those who work in the time series, they normally work on this particular part as well. So when we take the log returns of the stock markets, we normally try and see the standardized residuals, and then we program them in the Arch and Arch models accordingly for forecasting another part of it. So that's a different story altogether. But as of now, I'm just selecting everything to show you what we are going to get. We are going to the output, and let me take the output on a new worksheet because it is already very clumsy. So let me go to the new worksheet. The moment you click here, you'll get this line plot, line fit plot. You'll get the residual plot as well. So there are different concepts. We don't have that much time left for the day. So there is a concept of stationarity. There's a concept of homoscedasticity and heteroscedasticity that is tested by using these residuals all across. So that is eventually useful when you're using that number for further analysis. So not going in that detail as of now. These are the numbers. And again, because these numbers are again big numbers. So let me just reduce all these numbers to some readable decimal points. So 3 decimal points will do. So I'm just converting these numbers to that thing so that we can convert that information easily. And the basic information will be able to make some sense out of it. Right. So let me just highlight and explain few points here. And the same kind of output you get any software that you use, whether you're using R, whether you're using spaces, whether you're using anything, you'll be getting the same output. For some reason, this row is repeated in the Excel output. I really don't know the reason for that thing. I've been exploring to get that answer. So I just normally delete this. It's the same number that is already there. So now just to understand, what does it tell? For next 5 minutes, I'll explain this and then I'll take a few queries. You can ask any other thing that you want to ask related to the session theme. So very first thing is R square. So R square value is coming out to be 0.639. Now, what does it tell? It's a very, very important number. It tells you very important thing. I'm just writing in a simple thing here. 73.9% of the variation in dependent variable. Dependent variable in this case is C, is explained by selected IVs. So जो भी हमने whatever independent variables we have taken in our research, in this case they were A and B. So the 63.9% of the variation that is taking place in C is actually explained by the selected variable over here, that is A and B. 63.9% of the deviation that's taking place in dependent variable is explained by the selected independent variables. That is one understanding. Other way around of saying that is, there is, if you reduce this number from 100, so that becomes 36.1% of the variation in dependent variable C is not explained by these two variables. So there's something else which explains that remaining part of the variation, which is not being covered by these two selected independent variables. So that is one important part. Another thing that normally we ignore while writing our interpretations, but that's something very important when you are adding independent variables. See what happens normally. In nutshell, if I tell you what is the difference between R square and the adjusted R square, if you keep adding IV in the data, normally your R square tends to increase. So if you will add another independent variable, if it is a meaningful addition there, so then the R square value will tend to increase. And R square value, has this tendency of increasing by fractional point every time when you add one independent variable. There might be a time where you add one independent variable and this adjusted R square may start falling. And what does it mean? That you should not be adding that particular IV in the regression equation. You should stop adding IV, at that level. And at least that IV should not be added where the adjusted R square value starts falling. So adjusted R square plays that role. So it's like filtering whether you should add that IV in the model or not. So that you should keep in mind. Next thing is we normally get this ANOVA output also along with the regression output. What does it tell? It tells whether the regression that you are fitting in, whether the model that you are making is a significant dependency or not. So the value of C significantly is depending on A and B or not. So the null hypothesis here will be that there is no significant dependency of C on A and B. Alternate will become, yes, there is significant dependency. And here, because the p-value is less than 0.05, so we'll say null is rejected, alternate is accepted. That means significance dependency is existing. So just quickly, if you want to remember a few things, if you have not applied the regression earlier, if you have applied, then you already know that. So very first thing is R square value should be as high as possible. You must make sure that R square value is going as high as possible. Obviously, you cannot moderate and calculate that, but when you apply the analysis, it should be as high as possible. And then second thing is when you are going for ANOVA, you want for your prediction model to be, if you want to send some paper at some good journal, and if you're yourself telling that my significance of, dependency is coming 0.35 something, 660 something, that doesn't make sense because you're yourself telling your regression is not significant. So while running the analysis, you will pray that, okay, your regression ANOVA should have value less than 0.05, so that your regression that you are coming up in your model is a significant relationship. In this case, we are getting that answer. So 0.000 is a significant relationship. So this is usable regression model. आप इसको prediction में use कर सकते हैं. Second thing is you get this coefficients table here, and this allows you to draw the regression equation. So if I want to drag the regression equation here, I'll just quickly do that. So what will be my regression equation here? What is my regression equation? So my regression equation is going to be C is equal to 1.083. That is the constant value. That is the constant value. Then plus coefficient value for A is 0.823 multiplied by A minus, because next coefficient is negative, 0.091 multiplied by B. So this is how my regression equation comes up, and this regression equation is there. Now, another very important thing that we must look at before sending our work for publication or for any further review. See what happening here. This p-value section is also very, very important section that we must keep an eye before making any further conclusion. Intercept p-value does not make much sense, but at least the dependent IVs, the independent variable that you have taken, they should be clearly checked. A is having a significant value because it is less than 0.05, but B is having a 0.304 value, which is not significant. So even if I drop B from the equation, the regression will remain significant. But if I'm depending only on B, my regression will not be significant one. You have the data set, you know how to apply the regression. Please check that when you get time. So when you are applying only on A, your regression model will come significant. When you will apply only on B, why depending, why is C and independent variable only if you're taking as B, you will not be getting much benefit, much significant values there. R square value will not be that great. So that gives you a sign. This probably, B is not a significant predictor of C here. So we should not be continuing with B. We may try and get some other factor to predict the C component here. At least while making interpretation, we should keep it very clear that A is a significant predictor and B is not being the significant one. So that is one thing that we should always keep in mind while analyzing and doing the regression part. So what we have done in this particular part, we just started with the scenario tables. We discussed the what if analysis in the Excel, a bit of that calculations we saw. And then in the research part, I've just kept it very simple, not going very fancy over the hex stuff. So it has been basic understanding of the one-tail, two-tail testing, and how do we make that hypothesis testing work, and how do we read and apply some basic test in the Excel. And that's what has been the session learning. If you have any query, you can put up, and over to you, the organizers.
Thanks a lot, sir, for such a wonderful and informative session. And also giving us the insights about the Excel on the numerous aspects, because Excel is so vast then that we cannot imagine. So thank you very much, sir, for this insightful session. And at the end of this session, we would like to present a token of gratitude to you from our side.
Okay, sir. Thank you very much. Again, to see you on a different platform in a different university. Wish you great career in your profession, and hope you are the great teacher for many other universities as well.
Thank you so much, sir. Thank you, everyone, those who are responding in the chat box.
Small token of gratitude from our side, and we are very thankful to you and hoping to get associated with you in the future also.
Thank you so much, sir. Thank you.
So thank you, dear participants, for today's session. We will be meeting tomorrow with some other resource person. Thank you, Ankit, sir. Thank you again very much.
Thank you so much, sir.